Hello, everybody. It's me, Tim Dodd, the Everyday Astronaut. I've got a little treat. So, for those of you watching at home, you may have heard a little cheer there. That's because I am actually watching this in front of a live audience here in Belgium. So, say hello to everyone here at Nerdland who is actually watching us watch this live. This is a commitment that I've had for 6 months on the calendar to be able to speak here at this incredible festival. So this is fun for me because it's kind of the best of both worlds. I get to watch a rocket launch and I get to watch it live in front of people too, something that I've never been able to do. So yeah, hello everyone, welcome. Yeah. Oh, this is either going to be great or terrible. I don't know which way it's going to go yet. Okay, so anyway, sorry, I believe probably there's a decent chance my audio is going to be off. We're doing some crazy things to actually pull this one off. So I hope that it's okay, and thank you for sticking with us here. But let's talk about that beautiful rocket that's on the launch pad. We are looking good for today's rocket launch of the world's largest, most powerful rocket, which of course is Starship. This is the first version 3 vehicle that they're going to be attempting to launch for Starship's 12th flight, for Flight 12. And as you see on the pad, we're getting some good signs that we're making progress, because you'll notice the launch tower has a vent going on, so that does mean that they're cooling the tower down, cooling the lines down, and getting ready for propellant load. So that's a good sign. Yeah, I sorry again. I understand. Yeah, the chat's noticing that the audio lag is off because we're bouncing through about 20 different things to make this physically happen. So we're doing it on the spot. So I'm excited because this is a rare opportunity to be able to witness a rocket launch with a live crowd of people. I would have actually been down there in Texas, actually, with the folks at Rocket Ranch Outpost, who are lucky enough to be only 4 miles away, about 6 kilometers away. But this is the next best thing, I'd say. This is better than me streaming from a hotel room, that's for sure. So, yeah. So the venting is normal. I see that in chat, people asking, why is it venting? So right now, before they put the propellant into the rocket, the main thing is they're about to put cryogenic propellant onto the rocket, and that stuff's really, really, really cold compared to the temperature of the pipes that are going to feed that rocket. The pipes are really hot, basically. They're essentially boiling for that propellant. So what they do is they first fill it up with nitrogen, and then they let the nitrogen cool the pipes down and get it ready to start flowing fluid. That also purges the lines of any ice or any water. Because say they had a little moisture, let's say you had a little water in a pipe, and you're ready to load up something that's cold enough to turn water into ice. You could block, you could end up having a flow blockage by water ice. So they first purge it with nitrogen. Nitrogen ends up getting rid of, evacuating all the moisture. And then that's what they're doing right now, is they're basically purging the system. They're cooling the pipes down. They're getting ready to load the vehicle. And what's the next milestone we're looking for is at T-minus 50 minutes. Let's see. If the mic's hot, I might be able to... I think the mic's a little hot. If we could maybe... I don't know if that's on my end or your end or... Yeah, just getting to the truck. I think it's a little gainy. So, yeah. Sorry. We're so what I was going to say is what's cool about this is we're coming up on the next milestone being T-minus 50 minutes. SpaceX will be running an internal poll here for a go, no-go poll. And we have not heard, last I checked a few minutes ago before I went live, there were no updates specifically. So what I'm hoping we see is go for prop load. Actually, I see it now on X. They are go for prop load. That seemed to happen almost a little bit early, so that's a good sign. If they're go for prop load, which is again indicative of all the venting that you're seeing. So then at about T-minus 40 minutes, we'll actually, or just before T-minus 40 minutes, we expect to see that tower vent stop. Once that tower vent stops venting, that means they're actually starting to put propellant through the launch tower and into the upper stage. So that vent is specifically for that upper stage because the booster actually gets all of its propellant through 2 connects that are on the pads. They're down at the very bottom of the booster. And you can see the rockets, it's 2 parts, really. It's the Starship upper stage that from some of these cameras' perspective is black, and the shiny steel, the fully shiny part is the stainless steel booster. And that's, the shot that we're probably looking at right now, you probably can't tell too much. But that's those are the 2 stages of the ship. And okay, in Discord we're seeing a question. Is there from Spider-Man? Wow, everyone say hello, Spider-Man. Wow. Is there a backup opportunity tomorrow, or if a scrub today, will the next attempt be after Memorial Day? That is correct. The next attempt will be after Memorial Day. So in the U.S. we have a holiday called Memorial Day, and it's on Monday. So there are no streaming or launching opportunities Saturday, Sunday, or Monday. So the next launch opportunity, if it does not launch tonight, would be on Tuesday. And today there is a 90-minute launch window. So they start the launch window here. Locally for us, it'll be 12:30, or I guess 30. And that will run then until 2 a.m. Belgium time. And in the U.S., that's from 5:30 until 7 p.m. Central time. And there's the beautiful beast on the pad with its hilariously asymmetrical 3 grid fins. And yeah. So let's answer a few questions here from chat. Let's start off with, we've talked about this from Xerox. So I don't know if we're seeing that. We might have to refresh OBS again. But is the volume of gas coming out of the tank farm normal? Yes. So that is how they're cooling it. It has to be, you do expend stuff. You're venting out a lot of nitrogen. It's mostly what we're seeing at this point. And that's basically a refrigerant. And so as they expand it out and as it boils off, sometimes they can recondense some of it, but some of it it's better just to flow through things and have it be an expendable a commodity. Yeah, that's that. Let's see. Let's go to the next one here. Let's see. Yep, I am at Nerdland. Someone asking, is Tim coming to Nerdland? Hi, I'm at Nerdland right now. Let's see here. So this is a really important question. There we go. Cool, we got our chat working. So from Gianni is asking, are they going to attempt a booster catch? That's a pretty big question, and the answer sadly is no. Since this is the brand new version, the first version 3 booster, and a brand new launch pad, they are not risking bringing the booster back to the pad. So that being said, they're going to do some demonstrations with the booster. They'll splash it down in the Gulf, which is about 20 miles off the coast, so 30 kilometers off the coast. They will bring and simulate the booster coming in for a catch, but they will not ultimately catch it. They just want to make sure this new booster performs well enough to dare risk bringing it back down to the pad. So, this is a multi, I don't know about billion, but definitely hundreds of millions of dollars worth of pad infrastructure. And the last thing you want is a 200-ton ballistic projectile falling from space and it's crashing into your pad. So instead of risking that, instead they're going to validate that the booster performs well, and they'll likely validate that the booster performs well on the next launch as well. Flight 13, we're kind of expecting them to do a booster landing practice with off-nominal situations. So maybe testing out a steeper reentry profile or a engine out situation, or all the above, stressing the vehicle harder to make sure that it's safe to bring it back down to the launch pad for the catch eventually. So we might not see a booster catch until Flight 14. That's up in the air for now. But Flight 14 might also be the first opportunity to catch the upper stage, which is something that they have not done yet. They have never caught the upper stage. So that requires it going into orbit and safely re-entering and then being caught. So that'll be a huge milestone. Once that milestone's reached in the Starship program, then then we're making some serious progress. So that's the big one for me, and it's going to be pretty amazing. Let's see. Let's keep going. We already answered that one. So Stir Crazy Garage, what is the status of the next ship and booster? The booster is already being stacked and it's almost ready to have its testing campaign happen already for proofing as we speak. I think ship's a little bit behind it, but we're hopefully thinking about seeing another one in the next month or two, depending on how this launch goes. So that is kind of the deal with these iterative test flights is, they'll test something out, they'll see what happens, they'll see what breaks, what goes well, what doesn't go well, and then they fix it. So that might mean so what's happened a few times is they'll have one done. They'll have a rocket totally done and ready to fly with known flaws, and they'll still fly it instead of like sending it back in to get fixed. They already built it. So they're almost like reverse sunk cost fallacy. Instead of like, or that is sunk cost. I don't know. They'd rather just fly it and get data out of it and allow it to, maybe test some other things like, re-enter harder or do some things that they know are likely to fail so they can see where it fails and then they can put that into later vehicles. So that's kind of how that works. Like I said, we're coming up, hopefully. I'm keeping an eye on the SpaceX feed because we'll also be bringing in the live stream from them as soon as they go live as well. But like I said, the thing that we're looking for right now at this moment is going to be that venting to stop from the tower, which I'm looking at my multi-view here, and I still see it venting. But once that closes off, that's a pretty decent sign that they're beginning prop loading. But I'm not expecting that for the next 5 minutes or so. So we will see. We will see. Let's see. This is from Yakult 030. What are the biggest performance or reliability improvements you're most excited to see during launch? Any early visual cues we should look for? Yes, this is a great question. Thank you, mod team, for finding this. This is a very, very good question. So I think the biggest thing that you should see almost immediately is this rocket has a lot more thrust. And what that ultimately means is it'll get off the ground faster. It'll leave the launch pad even quicker than what you'd expect to see from previous launches. It has about 9% more thrust. And what that doesn't sound like a lot, like 9% faster, but it would actually be more than 9% because we have this beautiful thing called the thrust-to-weight ratio. So if a rocket only produces exactly as much thrust as it weighs, it's not going to go anywhere. So if you go from that standpoint, like a 1-to-1 thrust-to-weight ratio, if you increase it by 50%, you're actually increasing it by infinite. You're infinitely faster than the rocket that's not going anywhere. So if you go from a 9% improvement, it's 9% on top of your 1-to-1 thrust-weight ratio. It's beyond that. So it ends up feeling like 20, 30% faster, and it might be substantially noticeable. What that means is it's going to reach milestones even quicker because it's accelerating quicker. So those milestones will be, the callouts you're going to hear are going to be max Q, or maximum aerodynamic pressure. That's going to happen, I think it's about 15 or 17 seconds earlier than it did. It's closer to 40 seconds now. I've got the timeline somewhere. And that's absolutely crazy that they sped up. So what maximum aerodynamic pressure is, it's the moment where the stress on the aerodynamic forces on the vehicle are the greatest. And this is an interesting thing to think about because the rocket's accelerating in the atmosphere, but it's accelerating up. So for a while, the atmospheric stress is getting stronger and stronger because it's accelerating, right? It's flying in the atmosphere. But at some point, you're also going up, so the atmosphere is getting thinner. And at one point, those two things converge, and you do reach a point where you're going faster, but all of a sudden now the atmosphere is getting thinner, so the pressure actually starts to drop. So the point of maximum aerodynamic pressure is before that point. So it's right when all of the things are just at its peak. And that's kind of a decent sign of how fast the rocket's accelerating is if max Q occurs sooner. And now it's going to be occurring at 45 seconds versus pretty close to a minute. The next thing we're going to see is they call it, the normal term is MECO, which normally stands for main engines cut off. But SpaceX has coined their MECO to be most engines cut off. Because they have 33 Raptor engines, they actually will leave 5 engines lit in order to do a staging event. So they cut off most of the engines. Most of the engines shut down except for 5, and then they'll initiate this flip maneuver that'll bring the booster back down to the launch pad. And the upper stage then will continue on onto its near orbital trajectory. So those are the big things we're really going to be looking for, is just getting off the pad quicker, reaching max Q quicker, doing the boost stage separation quicker in the hot staging event. And yeah, that's going to be pretty exciting. And those things will happen already at 2 minutes and 22 seconds for MECO, and then 2 minutes and 24 seconds for hot staging. Now, if we have one of the tighter shots shows the staging ring, and that's going to be this is such an interesting thing, and it's something actually that the Soviet Union really pioneered. Yeah, look at that. In real time, we're seeing the rocket, or the camera zoom in. So right in between the two vehicles, you see kind of a lattice structure. Kind of looks like almost like serrated teeth or something, a trellis structure, a frame. And that's actually, not only is that structurally a pretty darn good way to hold a bunch of mass above it, because it's having to hold onto that, fully fueled vehicle with about 1,600 tons of propellant, plus, roughly, 150 tons of dry mass and payload. So you're talking about 1,750 tons have to be held up by that trellis frame. Those little triangles are holding the entire upper stage. And what happens is, instead of turning off the booster, pushing the upper stage, and then having the upper stage light its engines, it's actually more efficient to be able to just light the engines of the upper stage while it's still attached to the booster, and that's called hot staging. And that's going to be really fun because that's always a fun thing to see happen. And it's a pretty crazy thing. But there's plenty of precedence for it. The United States did it with the Titan II rocket. Like I said, the Soviet Union, and now Russia when they fly the Soyuz, or previously the Proton. The N1 famously had really cool lattice structures. So there's lots of precedence for it. SpaceX has been doing it since Flight 2, but this is a much cooler, better integrated hot staging ring. Let's see. We did that one. What about this one? Let's see. Your explanations will make this 10 times more enjoyable, like audible subtitles for foreign science films. Simple guys like me don't understand. Well, thank you so much to Eddie Willing for that. Just Jared 14. Hi nerds, love you all. Hopefully a great launch today. Yeah, we're hoping. I mean, I'm not hearing anything out of the ordinary, so that's always a good sign. The fact that it's actually going smoothly, it's going. Yeah, that's good. When we're not hearing stuff, that's actually a good sign. Like I said, kind of the next thing we're looking for is the vent. So the vent to stop on the tower. I'm going to do a quick little pinned chat. We know the audio sync is off. This is a very strange setup on stage in Belgium, cobbled together last minute. So pardon our, what should I say, mess? Pardon our mess. And then I'm going to do the grinny face. It goes like this. And pinned comment. Pin message. Okay, so yeah. For those of you that just happen to be tuning in on YouTube now, there's a handful of you. About 40,000 people are currently watching on YouTube that are hoping to see a rocket launch today, as we all are in this room as well. I am in a live studio audience here with a live studio audience in Belgium at Nerdland Festival. So, yeah, how cool is that? Yep, I spoke about an hour ago, did a little keynote with a. And now we're actually streaming in person. So this is a very last minute, like, hobbled together way to do a stream. But I figure, hey, if I have the opportunity to do something like this, we got to take it. So for those of you watching on YouTube, I'm sorry if it's not the normal best quality that we've ever produced, but I hope it's good enough. And then once SpaceX starts talking, we'll listen in and start paying attention to what they're doing, and then it won't be an issue. From Mango Slices are pretty good. What a great username. When do you get to go to the moon? Also, why does it use methane and not hydrolox? So I am not going to the moon anymore. Oh, yeah. There we go. Yes, now I'm feeling validated. For those unfamiliar, I was chosen to be part of a project called Dear Moon that was funded by a Japanese billionaire named Yusaku Maezawa, who had originally purchased a ride from SpaceX in 2017 to go around the moon. That mission evolved and eventually sold to him as a Starship ride, a ride on this type of rocket someday. And he got the opportunity to take basically as many people as he was willing to take up. And he ended up choosing 10 people to fly on a mission that he was planning to do around the moon. And I somehow got chosen. And then subsequently, about a year later, he canceled it after waiting 7 years for it. So unbeknownst to us, we didn't know that there was a clause that he could back out of the contract. But none of us knew that, so that was not the most fun thing. And it's always been a weird feeling to feel like almost guilty when something gets gifted to you but then retracted. It's like you have this weird guilt that almost doesn't feel warranted, but at the same time, it is still, yeah, something to note. So I am not doing that. But however, yesterday on SpaceX's stream, they did announce that Chun from From 2, who's the first human to ever fly above the North and South Pole for From 2 mission that was in 2025. He announced that he's purchased two more rides with SpaceX, both on Starship. One's going to fly around the moon, and one's going to do a flyby of Mars, which is going to be, in order to do a flyby, it ends up being something like almost 30 months, like 2.5 years. So yeah, 2.5 years in a vehicle. I would not do that one at all. From Congo Bongo 2009. Oh, we should probably also point out that the tower is still venting, so they are likely moving into their launch window a little bit here. I don't think they're on target right now for what would be 12:30 our time, a 5:30 liftoff time. I think it will move a little bit, but yeah, 40 minutes. Yeah, they're a little bit behind, but but hopefully we will see. Sorry, I'm having to do like time zone math and stuff. Yeah, ship LOX loading should have begun basically a couple minutes ago. But that tower vent there on the left side normally closes when they start to do that. But that could happen. Oh, it's starting to sputter. That could be a good thing. That could be a good thing. So we'll pay attention. Just keep an eye on that. But let's see here. Where was I? What was I talking about? Okay, so this is from Congo Bongo 2009. Since version 4, so the vehicle on the pad is version 3. Since version 4 Starships will require less refueling and be built differently than V3, will SpaceX bother making an HLS Moon Starship until version 4? So those of you that are unfamiliar, SpaceX actually got hired by NASA to be the lunar lander, to be a lunar lander, one of 2 lunar landers for the Artemis program. They got tasked to land humans on the moon. And guess what they did? Instead of building like a normal Apollo lunar lander or something, normal, they literally said, okay, we're going to land that skyscraper on the moon. Because the upper stage is literally over 50 meters tall, so 165 feet tall. And that's what they're trying to do, the 4 Artemis program, is land a quite literal skyscraper on the moon. Well, not quite, but yeah, you get it. Definitely will be the tallest human-made object on the moon, that's for sure. But what it requires in order to do that is a lot of refueling. You have to get a tanker up into orbit, and then you have to refill this vehicle because it's a huge vehicle. Its dry mass is like 120-ish or 100 tons, versus the dry mass of the Apollo capsule was like 4 tons. So we're talking about 25 times more mass. And in order to get it out to the moon, you have to refill it, basically. And the moral of the story here is you could easily launch HLS on a version 3 vehicle, and then it can still take advantage of new upgrades because it does rely on these refueling trips, and even relies on refueling trips for subsequent missions. The next time you go, the next time you're going to go to the moon and come back and get humans back from the moon, you then have to refuel that vehicle at the moon. And so HLS will take advantage of any upgrade that Starship makes. So I don't think they'd wait until, I don't think they have any reason to be like, oh, we better wait until we can do this with only 6 flights or whatever. I think it's in their best interest to get this thing going, start demonstrating it, and then they can lean on they will gain efficiency in these missions, just with upgrades to Starship. And we see upgrades happen often. This thing's only been flying for about 3 years now, and we've already seen it. This is the 3rd iteration, so they're on average about 1 major iteration change per year. So I expect version 3 to probably fly more frequently and fly and be. We're hoping to see this actually be kind of the first operational vehicle, the first vehicle that actually works, I guess, and then deploys a payload and reaches all of its full milestone potentials. And I expect to see it then operate for a handful of times, especially if they actually start developing a fleet. If they start landing and reusing the vehicles, then why wouldn't they just keep flying them? At that point, they're operational. They can start doing things like Starlink missions, and start learning how to do the fuel transfer missions and things like that too. This is from Rain Zufall 94, hoping this time it will launch. Greetings from Germany. I think I have a room full of people here that would really like to see a rocket launch tonight with a crowd of people. So yeah, I'm with you guys. Yeah, I was sad last night. I got some slack yesterday or online for acting, pretend or not pretending, but genuinely being sad that I wasn't there to see the rocket launch. And I was constantly saying things like, I expect this thing to scrub, because I did expect it to scrub. It was the first attempt ever of launching a new vehicle or a new pad. And that's normally a recipe for scrubbing. And sure enough, we saw it scrub. But the real reality is I'm sad that I was going to miss it in person, because of course I love this stuff. I want to see that rocket launch in person. And from this new vantage point, a place that I've never been to, which is the Rocket Ranch out in Texas. What's cool about that vantage point is it's just the perfect viewing angle now. So you're not only closer, but you're also looking at the rocket from the angle that we've been looking at most of the time, which is with the rocket here and the launch pad here. And you just get this perfect view of the rocket. So I want to be there. That's the reality, is this is a close second. I'm glad that I'm here with some awesome people. But the reality is, obviously, nothing beats seeing and feeling and hearing a rocket from that close. So it's hard to get the perspective always of how close. When you're standing there and you're only 4 miles away from something that's 120 meters tall that has more explosive energy than a nuclear bomb, Yeah, you feel it, you see it, your heart races just even thinking about it leaving the pad, and then when it does leave the pad, your breath gets taken away. It's absolutely magnificent. So, yeah, that's where I want to be. That's where I wish I was, but ultimately, I'm with you guys. So, yeah, cheers. Let's see. Mike became a member. Thank you so much. This is an important question. You guys tell me. Did you manage to get much sleep last night, and are you going to be partying tonight so you're on the red eye back to the States on Sunday? The reality is I got very little sleep because I was working on that thing that I presented to you guys earlier. So, yeah, like I said, I do want to point out the tower venting has mostly ceased. That is looking good. Actually, you can see propellant has loaded on Starships. You see the little white ring. See, you got the black side of the Starship vehicle, and then you've got the little white ring just above that arm that is attaching to it. So yesterday's scrub was because that arm has a pin that enables motion that they typically trigger. That pin comes out, and then the swing arm is free to move. That whole quick disconnect is free to move, and that pin was stuck basically. The pin was stuck. So okay, we are hearing that the SpaceX stream is live, and that we're likely going to be tuning in here to that any minute, and we will pull that up as well. And we will listen in because, again, I like to speculate and listen and learn along with them, and no one has better views than SpaceX for their own launch. So it is fun to listen in, and we will be bringing that to you as soon as the hosts start talking. We will be bringing that in for you guys. So, yeah, so stand by for that. But, yeah, the reality is I did not get a ton of sleep last night, and that's perfectly fine. Obama Gaming 49 asks, are these the version 3 engines? Yes, they are. The Raptor 3 engines that are just absolutely magnificent. They're the ones that are very simple looking. They don't look like they're finished engines. They have very little like wiring and plumbing, and everything's all integrated inside the rocket. So you just really, actually, we could probably pull the intro here. We'll show some clips of it. We could maybe throw a side-by-side up when we'll show the version 3, I'm guessing. Yeah, but we're going to get ready to listen in here. I'll listen in. We'll be passengers for a minute and get live updates. But, yeah, again, for those of you online, thank you for watching. Bear with us for any technical difficulties as I'm in front of a room full of people here in Belgium at Nerdland Festival. And, yeah. So we'll do our best. And thank you to our moderator teams and also the Spencer, who's basically running the entire show himself today in Texas. Hey, everyone here, let's hear it for Spencer for running everything. Yeah. There you go, Spencer. Yeah. So we're doing our best here. This is, making lemonade out of lemon. So let's tune in here, and we will watch the Starship launch, hopefully, together.
Once again, Star people, and welcome back to Starbase, Texas. It's currently 5:01 p.m. Central Time, and we are just 28 and a half minutes away from the first flight of SpaceX's next generation vehicle, Starship version 3. Yesterday's launch attempt was scrubbed due to a hydraulic pin on the pad tower that wouldn't retract. But good news, the teams were able to resolve that issue, and we're proceeding ahead with attempt number 2 and blue skies to boot. I'm Kate Tice, Senior Manager of Quality Systems Engineering.
And I'm Jake Berkowitz, a Lead Propulsion Engineer. And today we're coming to you live once again from just outside the production floor at Star Factory, where the team's preparing for Starship's 12th test flight.
Yeah, yesterday was certainly a nail-biter as we recycled to the T-minus 40-second hold a couple of times. And while we unfortunately weren't able to lift off, keep in mind that this is the first flight of a completely redesigned vehicle. So we actually learned a lot in what became a wet dress rehearsal yesterday.
Yeah, that's right. And Starship version 3 has undergone significant upgrades, taking everything we've learned from the previous 11 flights to make a vehicle capable of full and rapid reusability.
We're debuting a new launch pad, new booster, new ship, and new engines, just to name a few.
Yeah, that's right. And as a member of the Raptor team, I can tell you we're all super excited to finally see the newest generation of Raptor engines, also V3, take flight today.
I love that view looking up under the Super Heavy. Now, Raptor and Starship version 3 are designed to enable us to send payloads and eventually people all the way to the moon and Mars.
Yeah, and in the meantime, we're planning to put Starship to work on future flights by launching bigger and more powerful Starlink version 3 satellites, which aim to substantially increase capacity in orbit, strengthen the network, and deliver an improved experience for customers.
Now, turning our attention back to today, our primary objective for Flight 12 is to put these new redesigns all together in a real live flight environment. From the outside, a lot might look familiar on Starship, but beneath the surface, it's all new. As we've said before, Starship is still a developmental program. What we're doing today is a test. We launch to learn, and we test like we fly.
Yeah, and it's really the data we're expecting to get back from today's flight that will bring us closer to making Starship operational and unlocking the next generation of our future in space. So, no matter the outcome of today's test flight, excitement is guaranteed.
Now let's head a couple floors upstairs where Dan Hewitt is just outside our Launch Control Center. How's it going up there today, Dan?
It's going great, Kate. Everybody, welcome back for round 2. I'm Dan Hewitt with SpaceX Communications. We're looking good for a launch today. Do you want to do a quick summary, though, of what we saw yesterday, how we got back to launch? It's a really good example of all of the different moving parts that have to work together to get a rocket off the pad. About halfway up that tower, you see an arm that holds all of the propellant connections into the ship. It's also set up so it kind of pushes against the ship to help make sure that we have a really good connection, and it stays attached when we unlatch that quick disconnect. There's a pin in the arm near where that attaches to the tower that has to be removed before the arm can swing away for launch. It's important to remember there's a lot of benefit to not release the arm too early or too late, and a lot of hardware that has to work in concert in very, very short time frames. We started to unpin it. Releasing that tension caused some motion in the arm that triggered a hold, and that put the pin back in. Then that got us into a bit of a tug of war between systems on the tower that rely on hydraulic pressure to work. Really, the arm trying to keep its pressure on the ship and trying to pull that pin out. You saw we made a couple of attempts to fix the issue, eventually got the pin to start retracting again, but hit the same motion hold. Ultimately ran out of time. The team, though, made some hardware, some software changes to get us into a better position to fly today. We had the tower team up there last night. They welded in some hardware that's going to cut down on the motion of the arm as it's pushing back and the pin's released. And getting all the data we saw on how this hardware interacts in those critical moments, went in, looked at our software, all of our logic, see where we were overly conservative, where we may have had holds built on the wrong readings or the wrong times. Overall, though, really fast work by the engineering teams put us in a position for flight today. Heroic work by our logistics teams to get all the propellant out there. But things are looking really good for launch at the moment. Right behind me, all of the flight controllers on console, looking at the rocket, looking at the pad, looking at the range, all the systems as we count down to liftoff. Propellant load is underway. You can see the rocket getting frosty. We're on track to launch at the top of our window at 5:30 p.m. Central Time. Weather has been gorgeous. Thank you to everybody who was outside yelling at clouds that got us weather yesterday. It extended into today, and we are looking at a green range right now. Functionally, today's countdown, identical to yesterday, looks very similar to previous Starship flight tests. Some minor differences in timing on things like when we start propellant load, when the water starts flowing on the diverter, when our engines start up. But all the hardware is new booster, new ship, new engines, new pad. Let's do another quick look at everything that's debuting today with Starship version 3. As Kate noted, some of the outside will look familiar, but we've made extensive upgrades across the entire system. Big picture to Starship's still very, very big. It's just over 407 feet tall, fully stacked, a little bit taller than version 2, have more propellant in both stages. On the bottom half, our super heavy booster has some visible structural changes on the outside. On its top, we've got an integrated hot stage now, got rid of the one-time use one, so we're doing that for reusability. The ship's Raptor engines are going to be igniting directly into the top of the booster. That's where you're looking right now. All of that force and heat offset by the pressure inside the booster's fuel tank and a thin layer of non-structural steel. The grid fins on the booster, which we used to steer on descent, went from 4 down to 3, but we made them 50% larger. Higher strength, also use them for lift, and we'll use them for catch on future missions when we bring the booster back. We redesigned the fuel transfer tube inside the booster. That's what's sending all of that massive amount of liquid methane down to those 33 engines. Lets us light all 33 at the same time and have faster, more reliable flips. The bottom of the booster looks very different with those Raptor 3 engines. We deleted all of the bulky engine shrouds from previous generations, all of the prop avionics hardware, everything for that super tightly integrated now, protected by much slimmer shielding. Up on the second stage, Starship version 3 designed to carry massive orbital payloads up to 100 metric tons to Earth orbit, the Moon, and Mars. Biggest changes inside the vehicle itself. Propulsion system got a complete redesign, increased our propellant tank volume, improved our steering on orbit. In the payload bay, the PEZ dispenser is supercharged. That's going to increase the deploy speed for each of our satellites. We've got 22 payload deployables in there today. It's the heaviest we've ever carried on Starship. Eventually, we'll have up to 60 planned of those Starlink V3 satellites. Also on the ship, we added docking ports. There's 2 right below the payload bay door, 2 near the bottom. That's going to enable us to have starships link up in orbit for propellant transfer. Also modified the connection point in the ship to facilitate that. So a lot of upgrades tip to tail, and still powering it all is the Raptor 3. Now, those engines are manufactured in Hawthorne, California, tested in McGregor, Texas. Redesigned their ignition system, bumped up the thrust in the sea level and the vacuum engines, and then took all of the sensors, feed lines, controllers, everything that was kind of the busy sections around Raptors 1 and 2, and either deleted them or internally integrated and protected them inside the engine. That dramatically cut down on the weight, made it easier for those to manufacture. So, just an incredible amount of effort from the world's best engineering team getting this rocket to the pad, ready to launch today. I'm going to stop talking for a little bit. That was a lot. Send it back down to Kate and Jake for more on Pad 2.
Yeah, so like Dan was just saying, the team has been working hard on a brand new rocket, but we also redesigned the ground systems. And that brand new Pad 2 is making its debut today.
We took everything we learned from operating on Pad 1 to create this totally new launch pad. Pad 2 is optimized for full and rapid reusability. We've upgraded our propellant farm with much more storage and more pumps to enable super fast filling for launch and relaunch. And on the tower, we changed to shorter chopsticks. That's the black assembly there at the top of the tower, and that enables even faster motion to better track vehicles flying in for catch.
Yeah, and we also changed the actuators driving those chopsticks from hydraulics to 100% electromechanical, increasing their speed, redundancy, and reliability. On the ground, the launch mount was also completely redesigned, and if I had to describe it in one word, I'd say robust. But it's also smarter. We've separated the fuel and aux systems into different compartments and repositioned the booster quick disconnects to be out of the vehicle's plume during liftoff.
And as you can see there on your screen, we also have a new bi-directional flame diverter and a new top deck flame deflector to eliminate metal wearing down. So we said goodbye to the pancake. However, this will help us get to 0 refurbishment between launches. Now, this pad is still built for maximum safety and fast turnaround because making life multiplanetary will require launching a lot of Starships. Now, it's currently T-minus 18 minutes and 38 seconds. We're going to hop over to Hawthorne for a moment for more on Starlink with Tyler Lionquist. Tyler?
Hey, Kate, thank you so much. I'm Tyler Lionquist, and I'm a Starlink business analyst here at SpaceX. We're excited to be back here in Hawthorne, ready for another attempt at a launch today. So as we talked about yesterday, on today's flight, we're deploying 20 Starlink simulators, plus 2 modified Starlink satellites, which our team internally refers to as Dodger Dogs, because they stretch the V2 mini satellite propellant tank so that it sticks out from both ends of the satellite. And the Dodger Dog serves as a tech demo between the V2 and the V3 Starlink satellites, and acts as a platform for testing V3 components. Now, the larger V3 satellites aim to greatly expand our network's capacity, while V3 hardware is designed to support faster Wi-Fi and improved broadband speeds for our customers while providing significant capacity upgrades from the V2 Mini. So, in addition to delivering future V3 satellites to the Starlink network, Starship is also planned to launch our AI satellites. And as you may have seen during the TerraFab event in Austin a few months ago, Elon laid out the path to revolutionize cloud computing and AI infrastructure, leveraging the unlimited power of the sun, targeting 100 gigawatts to 1 terawatt of AI computing power annually. And from there, we're looking at connectivity beyond our planet too. Building on the technologies used to connect people on Earth, the Starlink team is exploring using Starlink to enable high bandwidth connectivity around the moon. With a constellation of satellites designed to connect to user terminals on the lunar surface, we could relay data back to our Starlink constellation in Earth orbit. So traditionally, deep space comms have relied on radio frequency transmission. But this new design would use lasers to relay data back to Earth, which can massively increase the bandwidth available to future lunar missions. We currently have thousands of lasers operating in our Starlink constellation around Earth, and deploying that technology around the moon could connect it with hundreds of terabits of capacity. Together, this could provide the connectivity backbone between the Earth and the moon, and enable gigabit connectivity anywhere on the lunar surface, providing data for rovers, habitats, and astronauts, and hopefully some incredible views for us back on Earth too. So all of that adds up to a lot of satellites, but the good news is there's still plenty of space in space. That said, the Starlink team takes space safety extremely seriously and works hard to encourage best practices across the entire industry so space stays open for as many people as possible. In fact, just yesterday, the Starlink team published a new update on Starlink.com to encourage all satellite operators to better coordinate and follow best practices to keep space safe. So for more on safety, go to starlink.com/updates. And with that, let's kick it back over to Kate and Jake and Starbase for today's mission profile.
Thanks, Tyler. Now let's dive into the flight profile for today's test. As we've mentioned already a couple of times, there are numerous redesigns making their debut today across the entire launch vehicle. In light of this, we want to keep our learning focused on all of that new hardware and software. So we're running a flight profile that's similar to past Starship flights in order to minimize any new variables.
Yeah, that's right. So as always, we start with liftoff, where Super Heavy ignites 33 of those brand new Raptor 3 engines. We power through ascent ahead of hot stage separation, where the booster shuts down all but 5 sustainer engines. Stage 2 then lights its Raptor engines while still attached to Super Heavy, where we see stage separation, debuting the integrated hot stage, directional booster flip, and engine relight for boost back using 33 engines. And after coasting for a few minutes, the booster today will target a landing burn in soft splashdown a few miles off from the coast of Starbase.
Ship keeps it going with ascent burn to a suborbital trajectory. Then we'll deploy 20 Starlink simulator satellites and 2 Dodger Dogs, as we affectionately call them. We also plan to relight a single Raptor engine. Next will be re-entry a few minutes later. For the first time in a while, we're intentionally not messing with Starship's heat shield. At that point, we should have some amazing views of the ship's Technicolor re-entry through Earth's atmosphere. If all of that goes as planned, we'll finish the test with a landing flip, a landing burn, and a soft water splashdown in the Indian Ocean. And in just a few moments, thanks to Starlink, we'll be going live to the Indian Ocean and chatting once again with the ship recovery team stationed out there.
Yeah, I'm super excited about that. That's going to be totally awesome. But sit tight, because first we're going to go to Dan for a quick status check.
Yep. Hey, everybody. Good news. Still looking good. Range is green currently. We're expecting another update on that in just about 4 minutes. That should be our final determination. Weather continues to look amazing. Vehicle and pad both looking healthy. We are a little over 80% on fuel, 95 on LOX in the ship, and then a little more than 2/3 it's looking like on booster. So we are on track today, looking good for a launch right now at 5:30 p.m. Central Time. All right, so we're going to do that right at the top of our window. Once again, though, we're going to be targeting to send Starship around the world for a splashdown in the Indian Ocean. We had a really quick check-in yesterday with the Starship recovery team out there on station. They're helping us to maintain the range and a whole lot more. So let's jump back out there once more today. We've got Suren Sunai joining us live from the boat deck out in the Indian Ocean, a couple hundred miles off the coast of Australia. Suren, how's it going, man? Welcome to the Flight 12 webcast. How's everything looking out there in the landing zone?
Dan, it's a pleasure to be here. I'm not going to lie to you, it's a little rougher than it was yesterday. Nighttime, it's hard to see the horizon, but we're looking at about 10-foot seas, and we're loving it, but it's rough.
All right, what's your guys' primary job out there? I mean, you're out kind of in the middle of nowhere. What are you guys doing?
So, like as you mentioned, like it's usually a 500 to 600 nautical mile sail from shore. And our primary goal is as a range clearing group. So like we come out here and make sure there's no one else in the area so the rocket can launch. But that kind of allows us to do our second goal, which is to conduct imagery of the rocket as it re-enters and as it splashes down. We get a lot of other data, but like the primary one is for sure imagery. with an ensemble of maritime and aerial-based assets.
And talk to us a little bit, because it's evolved over time, kind of humble beginnings of getting those views, to talk us through where we've gotten to now today.
Yeah, I think some people know, but like the Markset bots are quite identifiable. That's the buoys that we use. And they were originally used as sailboat racers. And we kind of put them in as a Hail Mary attempt on Flight 5 to get imagery of the rocket as it came down. And we all thought it maybe would have worked, but we were super shocked and really pleased to see all of the buoys pointed right at the rocket as it came down, which was a testament to not only the scrappy engineering we were able to put together, but also the rocket's ability to land right on target. And then since then, we've kind of iterated more and more, and these buoys have become way more robust and have now a lot more data collection materials, not just visual imagery. And as a result, they kind of are the most mature versions they've ever been. And it's really cool because almost all the buoys that we're deploying even now for Flight 12, we just got them off our back deck a few hours ago, are the exact same ones that were used for Flight 5.
And I saw a couple of user terminals. How Starlink kind of playing a role in this entire operation?
Dan, I'm not gonna lie to you. If we didn't have Starlink out here, we would be screwed. Like just on like a usual basis of like working, we're allowed to like have calls with each other and like work on documents with each other, send things to each other in like a very timely manner because of the Starlink on the boat. But not only that, each one of these buoys is equipped with a standard Starlink Mini, the one you would just get from like ordering it commercially, and that allows us to not only operate the buoy remotely, but also to get live stream data and telemetry, which is honestly super useful, and I don't think we have another solution for it without Starlink.
All right, before I let you go, what's it like? You're out there, and then all of a sudden, Starship appears out of the sky. What's that feel like, man?
Dan, I can't lie to you. It feels awesome. Just like being on the boat, not seeing any land for miles and miles, and then hearing the Starship crack down with its sonic booms and watching it breach through the sky, it is one of the most magical feelings on Earth, and really excited to feel that again today.
All right, well, thanks, Surin. Good luck, man. Hopefully we're sending a rocket your way real soon. Thanks for joining us in, man. I'm going to send it now back down to Kate and Jake for the latest progress we're making at Cape Canaveral in Florida.
Thanks, Dan. Now, if we want to get to the moon and then Mars as fast as possible, there's really only one answer, and it's to launch a lot more rockets.
Yeah, and to do that, we're going to need a few more launch pads and support buildings, which is exactly what we're working on over in Florida. So originally built for Apollo and then the Space Shuttle, Launch Complex 39A has flown 126 Falcon missions since SpaceX reactivated the pad in 2017.
Yeah, I actually remember the day that we did that. I was able to host
So
the live
Spencer, if I can
webcast
interrupt
for
you
that
for a
first
second, I want
launch
to
out of
address
Pad
the audiences
39A,
real quick.
and it was just so amazing to see.
So first off, I wanted to point out again, just so you kind of have a sense of this, we're within about 8.5 minutes, so things are actually going very, very well. They're going to show us some updates on 39A that we saw yesterday, but I want to take a quick second to again remind people online that we are running this. I'm in Belgium right now. I'm at Nerdland Festival in Belgium in front of hundreds of people right now that are here to watch this rocket launch. And so we've had to do some wacky things to even, string this thing together very last minute, because it turns out that this is where I was tonight. So I had to be here tonight. So please pardon, I pinned a comment about the audio sync. I understand I'm like 2 minutes off on audio sync. Yeah, so I apologize. We're doing the best we can, but unfortunately at this point, there's nothing we can do. So we're just going to enjoy a rocket launch together, hopefully taking off here in about 8 minutes. And we did just get a update from SpaceX on Twitter or on X, and it was the Starship recovery team is deployed in one of the most remote areas, and they're talking about Starlink, which we just heard about. So this is it's looking good, guys. I've seen enough of these to kind of know when things are feeling like something's going to happen and when things kind of feel like they're not going to happen. Knock on wood, but hopefully we actually will see a launch here at 12:30, and that would be fantastic. We have Jared Isaacman, so let's listen in here.
Here today, man. You had a heck of an entrance on the way in.
It's great to be here. Yep, certainly great to do a little bit of a flyby. I think they should accompany all the great rocket launches, and we certainly got a great rocket out there on the pad. But wonderful to be back, and no surprise, it's always changing here. It looks amazing.
I was going to say, it's been a couple of years. What was your impression flying in? It just the lay of the land?
Well, I think it was actually maybe 10 months ago. I was here slinging pizzas. I got a new job now, but it was. There's been so much that's changed even since then. Yeah, the facilities look amazing. All the housing that's coming in here, and of course, you got 2 orbital launch pads out there and a rocket that's just looking fantastic, especially from the air. It's good.
Yeah, you said you got a new job. It's been a slow start to your first 6 months. I mean, you only sent humans around the moon for the first time since the Apollo days. Bill and I kind of nerded out a little bit. Like, that was the last thing I worked on when I was at NASA, so seeing them go was just insane. Like, how's everybody feeling after the success of Artemis 2?
Well, I'd say I have the best job in the world, and I certainly work with an unbelievable team. I mean, as you know, that mission was a long time in the making, so I got to show up at the right time to see everybody put all that effort to put it in action. But what a great mission. Those 4 astronauts, you couldn't have had better ambassadors for humankind to the stars. I mean, they really brought us all along for 10 days, and we're getting ready for what comes next. We're going to start stacking Artemis 3. We got a lot of the hardware in the VAB already. We're hoping to even get out to the pad before the end of the year, do another wet dress. So,
all right.
And we're looking forward to seeing this thing fly, because hopefully at some point in the not too distant future, we're gonna join up in Earth orbit.
Yeah, what's coming up next, and ultimately, like, based on the moon, that's the big focus. Like, what's kind of the why? Like, why are we doing this for everybody?
Oh, well, I mean, and yes, we're certainly trying to get back to the moon, but what's coming up next? We're also building a moon base in parallel. And why are we doing that? Well, it's for a lot of the shirts I see around here, which is Occupy Mars. I mean, what a great opportunity. Go to the moon, return to the moon, build a moon base on the South Pole, interact with the water ice, right? Maybe work on some of those skills we're going to need when we're 4 days away from home for what we might need someday when we're 9 months away from home. But we got other things coming up too. You got Nancy Grace Roman, that telescope's going to launch later this summer. There's a lot of great, exciting things going on at NASA right now.
Yeah, man. All right. Well, SpaceX, we're custom built to try and make life multiplanetary. We're super honored, excited to be part of this entire Artemis program. Really excited to see Starship, sending people to the moon, all of the different pieces working together. It's going to be a really exciting future.
Oh, absolutely. Well, thanks for having me here. It's great to see everybody. Again, I know a lot of hard work leads up to a moment like this, so we're all rooting for you, and we're looking forward to meeting up next year in Earth orbit.
All right, man. Well, I'll let you jump back in there. Got about 4 minutes to go. I'll just toss it back down to Kate and Jake.
I think it's safe to say we could listen to you guys yap about the moon.
Something really important. So I have seen a lot of comments, and I'll get to as many comments as I can later on, probably during the coast phase and stuff. But I did want to do something really quick. I am an expert, might be a strong word, but I have a trained eye for a certain thing for the orientation of a launch vehicle. And I want to confirm with my training that indeed the rocket on the launch pad is pointy end up, flamey end down. So, yep. So they have my blessing. So yeah, let's listen back in here. We're down to the last 3.5 minutes till liftoff. So hopefully we see a rocket launch here tonight. That would be fantastic. So let's listen in.
Towards our second attempt. Once again, this is the first flight. We're aiming to fly for the first time, Starship version 3. Massive upgrades across the vehicle that you see at the pad there, as well as the pad itself.
The good news is we've had a pretty quiet countdown today. We are looking at a green range still, not tracking any issues with our weather, with the vehicle, or with the pad for a launch. We are now getting into the phase where we're closing out prop load on the ship, and then booster is going to close out in about 15 seconds or so. Once we're fully done with this, you're looking at 11.5 million plus pounds of liquid propellant on board Starship and Super Heavy. We're going to get the pad itself ready, push back all of the propellant that's in those lines running from the farm up to the launch mount, just kind of harden the area and get it ready for launch. We're going to peek inside, hopefully see the engines do a little wiggle as we do our final steering check. That'll happen at T-minus 100 seconds, and then after we get through T-minus 40. If you tuned in yesterday, you're very familiar. If we need to hold, we can go into what's called rapid recycle, essentially, where we can hang out at T-minus 40 seconds. It's built in. We're only going to hold if there's an issue, not currently tracking one. They can pop up after we pass T-minus 40, but right now we're looking good. Hopefully going to move right past that.
And then once we do pass T-minus 40 seconds, a number of events will occur in quick succession. That is when the QD vent gate, or quick disconnect vent gate, will clear the gas commodity lines that connect the pad to the vehicles. Both the ship and the booster will configure their comm systems for flight and will rapidly run leak checks on gas and fluid tanks. And the booster goes to internal power, and its engines will get their final priming for launch, while the ship's engines begin their ascent bleed profile and arms the automatic flight safety system.
Yeah, and once we pass T-minus 40 seconds, we still have the ability to rapidly recycle the count under certain conditions back to T-minus 40 seconds.
Looks like we might be getting some engine wiggles here, as Dan mentioned earlier. These allow us to check out the thrust vector control actuators on these engines. It's important to make sure that they can steer.
Yeah, that's definitely right. And flame diverter on pad 2 activates at around T-minus 17 seconds and enters what is essentially the point of no return at T-minus 10 seconds. If we have a hold close to T-minus 17 seconds, there's a chance we could recycle, but the closer we get to T-minus 10, the lower that chance becomes. We just heard we're at T-minus 1 minute.
Yeah, so at this point in time, we're going to stop talking. We're going to let the rocket take over and listen to some amazing pad sounds of the first flight of Starship version 3.
Okay, guys, this might be it. We might actually see a launch today.
All right, we are holding. We were just waiting for the fuel pushbacks to complete into the prop farm. We did hear that that did just complete, so expecting them to reset that hold shortly.
So minor little hold. They just get the flight pressures ready and everything.
Clock, the hold is reset, clock is rolling.
Flight directors go for launch.
All right, go for launch for flight director. Here we go. We might have a few funny extra sync things because the camera on the right is ours, and it'll likely hit us before the SpaceX camera. Deluge, here we go.
10,
ignition.
9, 8.
And it lifted
7,
off.
6, 5.
Yes.
4, 3. Ignition.
First version 3 Starship.
We have liftoff.
Let's go. Look at that tracking shot from Ryan. That is our own camera tracking that rocket. Beautiful shot. All 33 rocket engines. Looking fantastic. Look at the little roll profile they put into it. And that is looking like that thing is flying fantastic. All right.
Booster Raptor, chamber pressure nominal.
Tracking it. Actually, I'm flying through its own exhaust right now from all the exhaust rooms. So there we go.
All right, we are T plus 30 seconds into flight, seeing 33 out of 33 Raptor 3 engines on booster V3, ascending over the Gulf now, coming up on maximum aerodynamic pressure.
Booster and ship, avionics power, telemetry nominal.
Systems looking good. We're just passing through the period of maximum dynamic pressure.
Wow.
A little over a minute into flight now. Vibrations chilling out here at Star Factory as we continue to watch Starship Flight 12 arc out over the Gulf. The next major thing coming up is going to be hot staging.
Booster prop systems nominal.
Reminder, we do what's our version of MECO. Most engines cut off, so we're going to shut down all but 5 of the Raptor engines on the booster. And then after that happens, we're going to ignite the 6 engines on ship while it is still attached. We have clamps that hold the 2 together. Those are going to retract inside of that hot stage ring, kind of protect them. So we had 1 of the engines go out, still flying on 32 of the Raptor engines. But again, once we get the hot staging, those 6 engines on the ship are going to ignite. We're going to do it in a little bit different of a sequence on version 3. Essentially, those 3 RVAC engines will ignite first. Almost immediately after, just 1 of those central engines is going to ignite.
There we go, hot staging.
And that's going to give the booster a bit of a kick, sending it in a known direction, followed shortly after by the other 2.
Wow, that thing's scooting.
We're
So
through
our tracking
MECO.
camera from Ryan is going to be a little bit ahead of the SpaceX feed on the left. But we'll see that here now. There we go. Look at how quickly that booster flips.
There you go. Successful hot staging separation. We are not seeing as many booster engines ignite as we expected for boost back, but we are seeing 6 good engines lit on ship. It looks like we just had an early boost back shutdown. Again, a reminder, the booster was planned to essentially head into the Gulf for a splashdown, but it has shut its engines down early on into boost back.
Okay, so we're going to lose the booster.
And we just see
Which
one
we're gonna
of
lose
the
anyway, but
RVAC, so we're now running on 5 engines on ship.
Oh, they lost an RVAC.
We
That's
do
not
have
good.
engine out capability, so it's going to continue into its ascent. You got booster on the left there, ship on the right.
Ship avionics power
Again,
and
we are
telemetry
not
nominal.
planning on bringing the booster back for this flight, as this was the very first time.
An RVAC out is interesting because they can't steer those RVACs.
All right,
so
so we're about 3 minutes,
has a decent
50
amount of
seconds
offset thrust
into
now.
today's flight. Just a reminder that the ship planned to burn its engines for about 8 minutes and change. About 8 minutes and 11 seconds was our planned timeline for today. That could shift slightly as we do have 1 engine out running on 1 fewer RVACs.
Does Ryan still have the booster in that shot? I can't tell. If he doesn't, we could probably go full screen on SpaceX.
Again, continuing to watch. So booster did not complete its boost back burn. We did not see all of the engines ignite that we expected. Are continuing to get some views from it though. That's going to make a splashdown somewhere in the Gulf. Reminder: we clear air, sea space, everything for these launches.
So the ship is able to compensate by gimbling those 3 center Raptor engines to compensate for the 1 RVAC that's
All right, so we are coming up
shut down.
on T plus 5 minutes. Ship continuing to fire 5 of the 6.
Yeah, we haven't seen it do anything like this before, so this is a good test, I guess, of engine
Standing
out
by for
capability.
call-outs, making sure ship's on its planned trajectory. Again, we are planning a suborbital trajectory for the ship today. Booster giving us some views as it continues to make its way back down towards the water. All right, so a little over 5.5 minutes in flight. Kate, Jake, you guys with me? It looks like booster's starting to come in hot.
Yeah, we had the opportunity to stand outside to watch launch, and wow, that was incredible.
Yeah, that was really loud, really shaky, and I was actually surprised how fast the booster got off the pad, or the whole stack. That was quite incredible.
Absolutely. So we have views here from the booster coming back down, making its way into the Gulf. Pretty cool to see.
Healthy chamber pressures on 5 out of 6 ship Raptor engines.
Great news there
Landing
for
startup.
Starship.
This is not where it's supposed to re-enter, but they're getting good data out of what happens anyway.
And we were not going to bring the super heavy booster back to the tower. We were planning on having it land in the Gulf.
Surprised ship's still able to maintain that attitude like that.
And
That's
it looks
impressive.
like the booster ended its mission there in the Gulf, but we've got a ship still flying. Great to see that. Still have 5 out of 6 engines there on S39.
Yes, we also heard good chamber pressures as well on those engines that are lit. We do have engine out capability. We do see that we have one of the RVAC, one of the Raptor vacuum engines that is currently out, but that's okay. Ship is continuing on. Amazing views of planet Earth there in the background.
Yeah, I love the S39 decal there. That just gives the ship a little bit of character. And again, all these great views brought to you by Starlink, of course.
So it's still accelerating. It's going to need to get to about 27,000 kilometers an hour.
Obligatory shout out to the entire Starship avionics, camera, electronics team. did a whole lot of work to get these upgraded cameras. A look inside of the ship skirt, you can see those 3 center engines ignited. The RVAC's continuing to fire as well. We did see at least a couple engines fire up on booster for that landing burn before we lost contact with it.
So we
should have just a little over 20 seconds to go. We'll see if the burn extends a little bit for the engine out. Essentially, you can run your engines a little bit longer, or throttle up a little bit more to account for the one engine not being lit. So right now we are standing by for SECO.
I will be shocked if this thing survives once its engines are cut off and it makes it all the way, because it looked like an engine is very much on fire. And the one furthest from the cameras,
and again, we are continuing to go a little bit longer.
Like I said, it's got to reach pretty close to 27,000 kilometers an hour.
5 engines still burning on ship.
Keep going, buddy. The little engine that could.
You're coming up on T plus 9 minutes.
Yeah, so they're extending this to try to get all the velocity out of it that they need. It would normally stop burning at about 8 minutes and 11 seconds.
Shutdown. RVACs have shut down. Sea levels are shut down.
Okay. Okay. It's mostly in one-ish piece.
Get an update on the ship orbit insertion, but we have shut down again. We did run longer as we were engine out. We were flying with 5 of those 6 Raptors pretty much the whole time.
Ooh. I think that engine that blew up is venting propellant a lot. After it shut down, there's still a bunch of a cloud spewing from the far back side of the engine bay. So I think they're going to be losing prop. And eventually, that might be losing attitude control.
We definitely got a ship in space right now.
It's in space. Yeah. Yeah, it's in space. So I wonder if they'll still do the Starlink deploy. That will be coming up here in about 7 minutes or so.
The teams are incredibly excited to see Starship there in space. We are awaiting the call out of nominal insertion. So we're going to stand by for that. We can see the flaps moving here, actuating. But wow, the cheers here in the lobby are certainly almost as loud as liftoff was.
Yeah. Man, a lot of action going on. And, you know, we said at the top of the show, excitement guaranteed. And we're only 11 minutes in. We still have a lot more to go here on the mission today. So all objectives are done on the booster. So now all eyes are on the ship as we get ready for our in-space objectives.
Exactly. So like I said, we're still standing by to hear the call out for nominal orbital insertion, but we've got a few minutes before the next milestone. So we're going to continue. We've got some amazing views here of the ship. Wow, it's just that this is our planet. This is our home.
Yeah, that's pretty cool. So I want to point out that this likely is not on a nominal orbital insertion, and whether or not it is, they're going to study its trajectory. As a reminder, the objectives for ship today not only included the separation that we saw, but we're also planning to deploy 20 Starlink simulator satellites, as well as 2 Dodger Dog satellites. That's what our internal teams refer to as our newer satellites. We saw a preview of those earlier. We should see those deployments here in a little bit. We're also hoping to perform a relight of a Raptor engine as well.
Yep, that's exactly right. And the relight will look a little bit different this time. We're hoping to get a little bit of a longer duration. Of course, we got to see once we get there. And that relight won't actually be changing our orbit necessarily, but we're doing it more so as a technology demonstration.
So yeah, the fact that that one thruster's been the little RCS pod there on the side has been firing the entire time. I mean, it's working really hard to maintain attitude, and we'll see. I mean, we'll see if
for those of you that maybe just recently tuned in, you missed a pretty exciting almost 13 minutes. We had a liftoff pretty much on time, almost right exactly at 5:30 p.m. We did have a brief hold at the T-minus 40-second period, but we were able to proceed through that, and we saw a gorgeous liftoff. Jake and I were able to stand outside and witness that with all of our colleagues, and what a moment. I'll tell you what, it is a heck of a lot louder out here than it was at Ad Astra.
Absolutely. And a couple things I noticed on the way uphill today on the ship. So obviously it looks like we lost one of the RVACs on the way, but that is a good way to demonstrate our potential engine out capability there. So
exactly.
I think we actually saw the 3 gimbaling engines kind of gimbal over a little bit to compensate for that offset and thrust. So that was really cool. That's something I know the team's been, we've analyzed that since Flight 1 all the way back. So it's something that we've thought about quite a bit, and it was kind of cool to see it in action in real life today.
Yeah, absolutely. If you couldn't tell, Jake is on the Raptor team.
Yeah. But one non-Raptor thing I noticed also back on the when we had the shot of the aft flaps, it's a little weird. We have tiles on the leeward side, so not on the side where we're going to see heating. And you might be asking, why are we putting tiles there? I had the same question actually. So I talked to some of our heat shield engineers the other day, and we're actually running. Yeah, here's the shot right here. Great. So the fact that we're seeing all these tiles still on the flap right now is really good, because that actually was one of our experiments where we wanted to test different connection methods on the way uphill on ship, so actually ascent. So it looks like most, if not all, the tiles are still hanging on there, so that's actually a really good data point.
Looks pretty good to me. Now, once again, this view is from the side of Starship, which is basically the second stage of the Starship vehicle as a whole. This is one of the flaps on the vehicle that helps to control its position and attitude as it is orbiting, and also helps to control during re-entry as well. That's a critical phase. I mentioned earlier that we're hoping to deploy those Starlink satellite simulators, as well as perform an in-space relay of a Raptor engine. If all of that goes well, we will be targeting a soft splashdown in the Indian Ocean. We heard from Suren on the recovery team a little bit earlier. They are standing by waiting to
Spencer, why don't you
receive the ship.
duck them for a second. I'll explain something. So notice it is generally venting, actually. So it's not... So Starship has this weird thing, and it's half because I asked about it once. It's doing this, but it has... They use the pressure inside the vehicle as the propellants are boiling off to work as both. They normally have to vent it when it boils off, and it increases the pressure inside the tanks. And instead of just wasting it, they usually can use it for attitude control. Now, you notice that this is the first time we've seen the other side of the ship, and both of those vents are venting, so they're canceling each other out. So they're not really using those to maneuver. So that's actually good. That means that it's likely just dumping propellant at this point, which is something that they do. There is an RCS pod that just fired. That little, it almost looked blue. And so that's actually, I'm feeling better about this. I'm thinking that we're probably not too far off. So just wanted to note that. Let's go ahead and listen back in. Oh, that's actually really cool.
Headed towards the other side of the planet, and then a splashdown in the Indian Ocean. It's going to start to get darker. We're heading into an orbital sunset. So we're gonna have darkness for a little bit, and then it'll brighten up once we're on the other side of the planet, and hopefully looking at some good daylight when we re-enter into the Indian Ocean.
I really like seeing that one thruster fire. I like that it's blue. I wonder if they're actually doing some. Look at that. That one's really cool. I gotta figure out if that's just methane that's different, or why is it blue? Is it doing some mild combustion there? Is that a... Huh. Yeah, I don't know what that is, or why it's blue. It would almost suggest that it's combusting, that there's a reaction in there. It's not just venting.
All right, so we're a little over 17 minutes into flight. If you're just now catching up with us, we did see a liftoff right at the top of our window. Super Heavy getting off the pad, initially lighting all 33 of those Raptor engines, got through a successful hot staging. Initially lit 6 engines on ship, had 1 RVAC go out on the way uphill, but still able to make it into space. And right now we're trying to see if we are going to get into payload deploy still.
I think I saw the payload bay door open just there.
Coming up right on the part of the timeline when we were expecting it. You look inside a Starship there. Oh,
Yeah, you can see the door open.
I see a door opening.
So it's trying. This
Looks
is good.
like Hal didn't
How
wait. Pez
sick would it be
door
to see
is
the
open. Just a reminder, we've got 22 deployables in the payload bay today. 20 of those Starlink mass simulators, and then 2 are Dodger dogs, as we like to call them internally, sitting up their modified V2 Starlink satellites.
So
Those
they're going to
are
actually
be
take some
testing
imagery.
a bunch of components that we're planning to fly on Starlink V3, and we've also got them outfitted with a number of cameras for another tech demo that we're trying out on this flight. We definitely are looking for a way that we can look at Starship's heat shield while it's still in space. You can kind of only see so much from the cameras and the flaps. You can't see everything kind of on the underbelly, and one of the only ways you can do that is if you got something else flying near it. So we're going to attempt to our final 2 satellites going out the door have a suite of cameras on them that are going to be looking back at the ship. We're going to be in nighttime, and so we've got, sounds like we're getting into payload deploy. We'll be in nighttime.
Yes.
They've got some powerful flashlights on them to try and illuminate the ship's heat shield while we fly away from it. So we see some Pez motion.
All right, hopefully we start seeing the stack of satellites, dummy satellites, get ejected out. Here we go. Come on. Let's go.
Pew, pew.
Good, they're getting data. They're getting data. This is what we want to see. Validation, system testing. There's the first 2
down, 20 to go.
22. Unless it's a straight tech. Did you say you have...
As a reminder, that's one of the things that we upgraded in version 3, kind of gave a little soup up to the Pez dispenser, so those satellites going to move out a little bit quicker than they did on previous Starship flight tests. So first 2 out the door, 2 more on their way out.
Oh. There we go. You just see a sliver of it. The silhouette of it going out that door. And the other one.
All right, 4 down, 18 to go. Flexing my basic math skills here today. Again, the majority of this stack, 20 of these 22 satellites, they're essentially just mass simulators, so they're roughly the same size as those Starlink V3 sats that we're hoping to fly later this year.
There we go, 2 more. We're coming up on 6 out of 22. About a quarter of the way done.
And from this top-down view, so you're looking down at the stack, those 2 satellites you see on the very top, that they'll look very different. They've got solar arrays. They've got a bunch of other deployables on them that we're going to be testing out that are going to be V3 tech, and they've got 3 engineering cameras and then 1 other camera that's hopefully going to be giving us some views of Starship in space. But we will see how that works. Again, this very much a tech demo. We're going to deploy those. The satellite's going to kind of try and turn everything on, look back at Starship, and the primary reason we're trying to do this is to get some views of the heat shield.
What is that, 8 now out of 22?
2 more out the door.
Two more out the door, and I think that counts, or that comes up to 8 total.
As you can tell, the teams are stoked to see this demonstration happening. It's pretty incredible to see this happening live from space. Now, as we noted earlier in the show, but worth repeating, this Starship, version 3, is built to deploy up to 60 of Starlink's more advanced V3 satellites. Everything's V3. Designed to offer 60 terabits per second of downlink capacity per satellite. Now, that is 20 times more than each Falcon 9 does today. Incredible.
All right, I think that's number 10 going out the door.
Okay. So almost halfway done.
Yeah, there it goes.
Hopefully everyone here at Nerdland will be able to get this before they give you the boot.
So yeah, the camera view you have on your left screen there is basically right at the bottom of the payload volume. So the kind of dome-shaped structure you see there that's actually the top of the fuel tank.
Then the camera view that you have on the right is an external camera that we have positioned so that you can see basically the light through the open PEZ dispenser door that you see. That's that sliver of light. We can see the Starlinks here deploying as each one comes through.
Okay, over halfway. That'll be the last two that are the exciting ones.
As we mentioned, we have 20 of these Starlink simulator satellites, and then we have 2 of these specially modified, as we call them, Dodger dogs here around here. Those, as Dan mentioned earlier, they have some V3 tech on them, some solar arrays, and those will be the last 2 that will be deployed today.
Yeah, that's right. And seeing this, as I think Dan called them turbocharged or supercharged PEZ dispenser, it's definitely coming out much faster than our previous flights. So that is really good to see. Yeah, look at that.
13 and 14, right?
And especially once we, fill Starship up all the way with around 60 or so of these Starlinks, being able to deploy them fairly expediently, is going to be important for designing the overall mission profile.
Yeah. Now, fans of Starship may know that Starlink enables lots of unprecedented views, both from space, as we see here, and on Earth. In addition to the dozens of cameras on Starship itself, we also have mobile Starlink camera kits deployed in the Indian Ocean.
Yes, Starlink also connects our aerial cinematography units on the ground at Starbase and at other strategic camera spots around Texas.
It's all part of how it all comes together to tell the incredible story of Starship both on and off planet.
Yep.
All right, we're getting low on the stack. It looks like we got 2 more of those simulators to go out, and then it will be time for our Dodger Dogs, those modified Starlink satellites. Just a couple of updates while we continue to watch Payload Deploy. Did get confirmation we're going to be skipping that relight of the Raptor engine, just due to everything that we saw on the way uphill. Those sea-level engines, we're going to use them for a landing burn, though. They are still capable to be used for that. So we'll still look to do a controlled landing in the Gulf, but no in-space relight.
In other words, the in-space relay normally
I think
would
that's
extend.
19 and 20 headed out the door.
Okay, so now it's
coming up our Dodger Dogs. So these are modified V2 Starlink satellites. We do have a number of cameras on these that are going to attempt to look back at Starship. We're not going to get this video in real time, but we're going to try and turn it around if we do get some video down. So don't worry, if we get views of Starship from these satellites, we will be sharing.
That'll be really cool. This is something I've been looking forward to. So
these will be exciting because, again, they're really a tech demo. getting our chance to test out some of the technologies for version 3.
Okay. Let's hope for some views from these Dodger Dog
I think
satellite.
that's 18 and 20. My basic math skills are failing now. All right, here we go.
Okay. Here we go. This is the Dodger Dog, whatever they're calling it. It'd be cool if they show the camera from on the satellite
We're
as
standing
it's
by for
leaving.
Starship,
That'd be sick.
basically to serve the first Dodger Dogs to low Earth orbit.
Well, not quite low Earth orbit, but close. Oh wait, maybe these ones would have enough propulsion to fly, but that'd be pretty sick.
One out the door.
Okay. Okay.
In this view,
Big
you
moment.
can kind of see on the right side of the satellite, you see some bright white spots. Those are our flashlights. Beneath them, the camera is going to attempt to look back and image Starship's heat shield as it flies slowly away from the vehicle.
So
There
the
it goes.
camera. Oh, that's the flashlight looking in. This is still
Let
the
there
payload
be
bay.
light.
The
Yeah, it
headlights
almost
on
looks
the
like the light is
satellite.
just shining right at us
Oh, that's
there.
cool. That's cool.
If you couldn't
But
tell,
now, do they
we're
roll
pretty
the vehicle or
excited.
do they kind of fly
Yeah.
it around?
It is always sunny in space.
Always sunny in space, and that looks like an empty payload bay. So
Sure does.
that's exactly what you want to see there. That's great. So yeah, with payload deploy complete. Oh, you can see the door closing there. All right, there we go. So yeah, with payload deploy complete, Starship will now close its.
Oh, they must have the views. They must have the view. Or is that just a fearful payload bay?
Yeah, Starship, we closed the payload door, and we're going to continue to coast around Earth all the way to the Indian Ocean. So still a lot of major events to come today. Sounds like we're not going to hit that Raptor relight based on what Dan was saying, but after that, of course, we'll have the atmospheric reentry and splashdown. And with that, we're going to go on another quick coast.
So sit tight, enjoy some amazing space views and the space jams, of course. And we'll be back in a few minutes for Raptor relight, or excuse me, not for the relight, but we'll be standing by for atmospheric reentry.
Okay, so chat, don't go anywhere. We'll stick around. But I do have to say goodbye to our friends here at Nerdland. Thank you guys so much for joining, staying up late. It's 1 a.m. Thank you guys. Thank you so much. It's really been a real treat for me able to live stream in front of a crowd of people. You've really made this one special for me. So thank you so much, sincerely. Enjoy the rest of your weekend. Oh, we did have some people that were in the audience that were super chatting. So Jerry Barry, and hello to little brother Sam in the audience. I did see some people out there. So sorry that I missed that earlier, but thank you guys so much. Have a great rest of your Nerdland weekend. Hopefully I'll see you around. So yeah, cheers. All right, and for the rest of you guys still tuning in, and you guys that are in the room as you're leaving, you can still watch on YouTube. I'll still be live until Splashdown, so probably another, oh God, a little bit. So, so another night of very little sleep. But it's planning to do the landing burn at 1 hour and 5 minutes. So that's coming up in just over 30 minutes. And then, yeah, I'm going to go ahead and answer a few more questions here as the crowds leave here in Belgium. This was a long time ago from Michael Busby, approaching T-minus 45 minutes. And that's still a flap camera. I'm trying to keep should halfway pay attention in case we do get to see that footage from those satellites. I'll try to call it out. Let's see. From Paul Mitchell, love your videos and streams. What do you think the minimum achievement need to be today in order to consider success? I would consider this a success. The fact that we have a vehicle in space and it was able to deploy the Starlink satellites, that's a huge milestone. The fact that they're able to fire up and test the Raptors and everything, that's pretty fantastic. So things are looking good. Obviously they could have gone better. I really wish that the booster had gone better, because that ultimately means that they're going to have to delay the catch attempt, because now they would lose some confidence and they'll probably have to wait for another flight to be able to do that. So hopefully yeah, hopefully the next flight goes better for the booster. I'm really curious what happened, if it was something with like the downcomer or something, what caused those engines to not light and what caused it to ultimately be shut down. So let's see here. So Benny Z, now Elon has just floated SpaceX on the stock market. Do you see that as a positive or negative situation moving forward? Well, they're doing such a small, it sounds like they're relinquishing such a small amount of shares to be publicly shared that I don't think it's going to change too much. And here, we've got a lot of people out here. I'm going to real quick come say hi, and everyone get your phones ready. I'm going to swing by, get your phones ready. I'll wave to you guys, and I'll take a picture right now, and I'll give you about 10 seconds. Ready? Ready? Okay, real quick. Sorry, stream. I'm coming like this. Hi, guys. Oh, no way. Hey, that's awesome. All right, get some pictures. Oh, selfie mode. Thank you guys for sticking around and staying up late and watching a live stream. It really meant a lot to me. And thanks for coming to my speech. I hope that you guys have a great rest of your Nerdland Festival weekend. It's been really impressive to see this place. Yeah, it's been really, really fun. I've already... Oh, I love to hear that's the ultimate compliment, becoming an aerospace engineer. I love that. Thank you guys so much. Sorry I don't have time to individually say hi, but thank you guys. Cheers. Okay, chat. So let's see here. Do you think they're going to hit the late 2027 target for Artemis 3? Also, hi from the audience. Another from Joe K. Blick. Hey, yeah, all right. Thank you. Oh, nice shirt. Holy cow. Oh, a new one even. You're on it. Thank you very much. That's awesome. Well, I'll answer your question. I think they could easily huck an HLS simulator or some kind of stripped down HLS into orbit to be able to do a docking in 2027. Will it be an operational vehicle that can go on to do the mission? I don't think so, personally. Well, I mean, maybe. I'm not going to say no, but that seems unlikely. I feel like if they had to demonstrate something, they could throw up kind of a simulator in time. So we'll see. Thank you. Let's see here. Why not build a huge version 5 capable of refueling V3-based HLS with one trip? That would be, I mean, we're talking about an order of magnitude bigger. We're talking about you'd have to make a Starship 10 times bigger, literally. 10 times more capable and bigger. Did I miss the Dodger Dogs? Yeah, sorry if I'm missing something. You guys let me know. Sorry, I've been having a hard time trying to juggle like 5 things at once between traveling, speaking here, and all this stuff and everything. It's been crazy. What is that one of our cameras on the ground, Spencer? That's under Hopper flipped over. Oh, that's crazy. That's funny. I was wondering what that was. Let's see here. Are there any environmental problems with dumping these in the ocean? The reality is rockets traditionally have always been dumped in the ocean. This is a program that's working really hard to not do that. That's the whole goal of this entire project, is to not do that. And sometimes the best way to eventually get to do that is by having to throw a few away. And that's no different than the last 60-some years of spaceflight. That's just the reality of what most rockets do and what most rockets historically have done. So, no, it's not a huge environmental impact compared to the grand scheme of everything. Is it an environmental impact? Sure. Is it getting better or worse? The answer, I think, would be it gets better if you try to be reusing all your hardware. So, this is from Jan Jeffrey. Looking forward to the launch. Please say hi to Scarlett in Ashford, UK. Well, thank you so much. Or Ian Jeffrey. Thank you so much. That's very, very, very generous of you. Thank you very, very much. Let's see. This is from Andy. They have shortened the chopsticks on the new tower, but they look like they're too short to place the booster back on the launch pad. Watching from Leeds. Yeah, I don't quite know how they're going to do that. I assume that they thought of that. Worst case scenario, they likely will be placing it back on a transporter stand and then transferring it from there, re-pick it up and put it on the booster, or on the stand. But it'll be a while before they do that anyway. Who knows what's going to change between now and then? Let's see. You mentioned sooner max Q, but is the pressure higher, lower, or the same? I don't have those numbers. That's variable. That is a thing that the actual Q or the peak pressure is variant on a lot of things that I don't know anything about. So it could be higher, it could be lower. It likely is higher though if you're doing that sooner. So that would be my guess. Actually, I can't. Now that I think about it, I don't even know if you could have it be lower a lower max Q in the lower atmosphere. That's breaking my brain thinking about. Thank you, Ryan Voorhees. Good to hear from you. Smooth Juice 10101. Quick quiz. What date did Starhopper fly, and can we hear the famous 4 words? Please, I will never forget. Let's see. I think Starhopper flew on August. Ooh, what is this? Is the views from the satellite being ejected? I think. Right? Yes. Oh, that is so cool. Are you kidding? That's what I've wanted to see this whole time. What a cool view. Oh, that is fantastic. You can see those weird circular things. Those are the docking ports that they'll eventually dock ship to ship with. Man, that's really exciting. So how do they view the heat shields? That's what I don't quite understand. Are they expected to roll Starship? Or are they just looking at the heat shield tiles that are on? Maybe that's why one of the reasons they have so many extra heat shield tiles on this side of the ship, so they can look at those, know how they held up during ascent. That probably is all it is. They probably don't even need to look at the heat shield tiles on the windward side. They're looking at all those experiments that you would normally be out of camera range. That's really cool. Big fan of that. Yeah, that's excellent. So water towers can fly. I think it was like August. Well, I think one of them was August 27th, and water towers will fly, and that was 2019. Yeah, I think August 27th-ish. Not positive. Around there, maybe August 20th or something. Nathan Lewis videos, thanks for great content. Also, heads up, your videos delayed, but yes, I am fully aware. I am fully aware that our audio and video is fully out of sync, again, because of the way we're doing things here. Just in, Joe Killer, hey, Tim, what are you most excited for this launch, and what do you think the most likely to not go to plan? Well, apparently the most likely thing was the booster, splashdown and touchdown was ended up being the thing that did not happen. Thunderbird, Captain Scarlet, or Space 1999. I just learned about Space 1999 this morning from James. I thought that was really cool looking, actually. I was unfamiliar. Perry El Hornitorico. Hi, if future versions of Starship are going to be taller overall, does that mean they'll have to extend the launch tower, or the current tower be able to support the eventual increase? Depends on likely they built the tower with some margin to extend it a little bit, but I think they could always increase the height of the tower. They can cut, weld, and replace and make it taller if they had to. We are starting to get into kind of atmospheric reentry, getting close at least. You can see a few signs of kind of, when the thrusters fire, noticing the gas is coming back. So that's a sign that there is some atmosphere hitting the vehicle already, and that will start to build up and turn into a plasma that we're so used to, the beautiful iridescent plasma. Do you think SpaceX will eventually launch crew on Dragon to dock with Starship already in orbit rather than launching on a ship with no abort system? I am still very curious what the overall end goal, the end result will be for that, what they'll end up doing with the abort system. It's really hard to tell if they'll ever fly humans from the ground on Starship, or if they do, how many successful flights will they want? So, by the way, the vehicle is flying into daylight now. So, by the time it splashes down, it should be daylight there over the west coast of Australia. So it's still flying through the night at this point, but it'll start to hit sunlight here pretty soon, which will be really fun to see. Let's see. Am I doing a meetup in Ghent tomorrow? It's a beautiful city. I sure am. I posted it on for any supporter. So if you're a supporter on YouTube, on Patreon, or on X subscribers, I made a post of where we're going to meet up in Ghent and the time. So as a thank you to supporters. So if you are a supporter that lives anywhere near Ghent, Belgium, come say hi tomorrow, and I'll be hanging out for a while. So assuming I get lots and lots and lots of sleep tonight, I am going to not set an alarm. And I'm going to sleep as much as, I have been on very, very little sleep the last few days. So let's see. From Chris, Sticky Frost, when you're in Berlin. I'm not quite in Berlin. I am in Belgium. Slightly different. Thank you so much. From S. Shiretto, how many Starship launches do you personally predict in 2027 and 2028? Okay, my prediction at this point, after seeing the first one fly, I think we'll see Ooh, I think we'll see 4 more, maybe. I hope to see 4 more Starship launches this year, and I hope to see like 10 next year. So 10 for 2027. Oh, that's for 2027. Okay. So 4 this year, 10, and then I hope by 2028 we're flying if there's like 35 or 40 or something. Let's see. This one's out of admiration for you explaining calmly and respectfully that you're not going to moon for the gazillionth time. Love from Germany. Well, thank you very much. I've had to do it a fair share in my day. Abidam3312. What is the point of venting? Is it to chill down the tanks before they add the propellant? So the venting that you normally see on the tower is to chill down the actual tower lines, the actual fill lines. But also the vehicle does vent. They also still want to purge the vehicle of any moisture, and they use nitrogen to do so. Yeah, hopefully that explains that. Brig Moores, is there any expectations of Starship going wider than 9 meters? It seems like 9 meters is the upper limit for rockets, but something like 12. It's definitely not the upper meter or the upper limit. The limit is just manufacturing and your launch infrastructure. I would definitely say that yeah, the reality is 12 meters is no problem really, as far as if you have the infrastructure to handle it. If you have the ground vehicles, the launch pad, the assembly for that. Don't forget the Saturn V that took, or that or not the N1 that they were planning to launch for humans to the moon for the Soviet Union. That was 18 meters wide. So we've built rockets much wider and bigger than Starship. And right. Let's see. How does SpaceX pay for the consultation of its vehicles and ground infrastructure? And if we know how much are they spending, I think the word was construction. Probably got autocorrected as consultation. How do they pay for it? Well, they have investors. They pay for it with Starlink revenue as well. That is a cash positive thing. So they are a profitable company, and that's kind of likely what's funded most of this. Also, investments from NASA and other government institutes have also helped fund some of this program. But with, people think that it's like it's some kind of subsidy or something. The reality is those contracts that are given to, sadly, I still do need that monitor up if that's okay. Can we just plug that in via like HDMI or something for now? I lost my monitor there. Yeah. Cheers. Thank you. Yeah, we don't know how much I spend a year. That is all private. Let's see here. This is from Parker Tazelier. Tim, you just keep being you. Appreciate you and your team. Well, thank you so much. I really do appreciate that as well. Did the Starship lose all the fuel from yesterday's attempt, or do they have the ability to recapture? They recapture a decent amount. The rough estimate is about half. That's what I've heard, is that they can recapture about half. About half of it is lost to boil off, unfortunately. Why does Starship have a skirt? Surely replacing the skirt with lattice similar to the hot seat would make sense. I've wondered that too. I wonder if it would offset, if it would make for asymmetrical thrust on the upper stage. I'm not sure. I'm not sure what the exact reason is, but I've always thought a lattice at least on the leeward side would certainly make sense. So all right, we're getting into some more serious amount of reentry. So this is looking good. I'm happy to see that it's making this much progress, because obviously the further it gets into this, the more data they get, hopefully the more they learn, and the better the next launch goes. I know it's not the shuttle, but hearing GLS is go for auto sequence start, which got me set for launch. Yeah, that is very cool. Let's see, from Six Hand. Can you talk about the Baby Raptors, the gas generators that run water deluge system? Any changes with the new launch pad? 1 million changes to the new launch pad. I highly suggest, if you want to learn about those Baby Raptors, watch CSI Starbase's in-depth series. He has a very long video that just came out specifically about those. I haven't even had time to watch it at all. I will be watching it probably on my flight home. If you want to know about it and know about the launch pad, I highly suggest watching that. Yeah, that was literally just messaging you. That's perfect. Give me 1 second here to prepare for that. And if you're ready, Spencer, you let me know. Then I can't see it now, ironically. Yep, cool. I just wanted to give a quick shout out to our shop. If you guys want to support the work I do and get some cool merch for yourself, we do have our new Translunar Coast collection out that is now shipping. All the pre-orders are going out the door. If you want to take 10% off, you can use Starship 12, all uppercase, all one word, Starship 12 in the coupon code. You can get our new Orange to the Core shirt, which I absolutely adore. It's a nod to the thing that makes the compound that makes SLS have that orange color. I'm wearing the slow roll towing shirt, which I also love. This is going to be in the dark. I can't hardly see what I'm doing right now. This is the shirt that I'm wearing today, which I absolutely love. And then lots of other fun stuff. And we have anything in our Translunar Coast collection, including we do have new kids shirts as well. So if you have youth, we have these in youth sizes as well that we're taking pre-orders on. Oh yeah, we also have this keychain. I don't actually have a keychain yet. I don't have it in my possession yet, so I'm really excited to see this because I think it's absolutely adorable. But we also are doing that same discount for anything in our heat shield collection. So that's going to be like our heat shield button-up shirt and lots of other fun stuff. So if you want to support the work we do here, most fun way I think you can do that is by going to everydayastronaut.com/shop. And then, yeah, like I said, use coupon code. What's the coupon code? Starship 12, all uppercase, all one word. I am starting to lose it. I am clearly feeling the sense that I have not slept enough in the past few days, and it is extremely late, and we are seeing a rocket re-enter. So let's go back to that, and I'll tune in here. Thank you guys again, though, for supporting the work we do here. I know that this is probably not the most ideal stream for you to watch from home. I know there's a lot of issues. I know we're having to absolutely wing stuff, but this is the best I can do with the life that I have. And, you know, sometimes that's the best you can give is everything you got. So I'm trying my best. Our team's doing a phenomenal job being flexible and trying to work on these issues that we have when I'm trying to stream from a stage in Belgium that we just did not expect to happen. You know, of course, that's always a possibility, but you just never know. So it is, yeah. Look at that. You can see the plasma really starting to glow now. Like we said, we're hoping to see re-entry here kind of reach its peak. Is that burn through on the flap, or is that just coming off the back? I think it is just coming off the back. I don't think that's burn through. We do expect, though, to see the peak coming up here soon. Is SpaceX talking? They're not talking yet, are they? I feel like normally by now... I feel like normally by now they kind of start updating us, but at 1 hour and 2 minutes would be transonic. So we're coming up on, we're well within it, you know, obviously in reentry, and I don't know what peak heating would be. It'd probably likely be sometime in the next, between now and 10 minutes, would be peak heating during this reentry profile. Again, remember, this is a suborbital mission, but it's just barely suborbital, so the data on reentry is really one of the most valuable things they can get. Is
because it's re-entering at or around orbital velocity, roughly 8 kilometers per second, or for those of us that think in other units, roughly 5 miles per second. At those speeds, the spacecraft is moving through the atmosphere, and it creates that plasma field that we saw forming around the vehicle.
Yeah, and although the plasma looks really cool, it does distort some communication frequencies. So it's not uncommon to experience brief blackouts in communication. Of course, thinking long-term here, Starship is designed to land on Mars where there are no runways or other humans to help out. That's why we're going with the propulsive landing instead of a more traditional means like parachutes. Propulsive landing, not only, again, is it more cool, but it enables a more rapidly reusable rocket.
Yeah. Now, we should hear some call-outs as the ship makes its way back to Earth. When we hear entry max heating and entry max Q, that means the ship has made it through the maximum heating and aerodynamic loads that it will experience as it returns. So if we make it through those, we're doing pretty well.
Yeah. And you can see in the bottom left right now, we're at 23,500 kilometers per hour speed. That's just a crazy number to think about. But as we keep progressing in the mission, we are going to hear a call out when the ship is transonic and then subsonic. So transonic refers to the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, kind of in that Mach 0.8 to 1.2 range. And for reference, commercial jets have a range of cruising speeds, but mostly fly around Mach 0.74 to Mach 0.85. And after we hear the call out that Starship is transonic, we should hear the call out when Starship is subsonic. This refers to speeds that are much less than the speed of sound, so at this point in the flight, ship's velocity will be slowing down.
We definitely have a crowd still here in the lobby of SpaceX headquarters down here at Starbase, Texas. Everyone is, loves watching ship re-entry. It's always such amazing colors. This must be what it feels like to be one of those praying mantis shrimp or mantis shrimp. Can't remember exactly what the name is, but the ones that see in billions of colors. This is the closest I feel to being one of those.
Yep. I think one other thing that's cool to point out right now is look in the bottom right. You can see where we are on a globe there. We're squarely in the Indian Ocean already, and we've only been flying for 53 minutes. Yeah. So pretty crazy. We went all the way from Texas to the Indian Ocean in less than an hour.
Yeah. She flies pretty fast.
She flies very fast.
So I wonder, if the plasma color difference is camera settings. I assume it is. I don't think that's going to change much. I think that's all just white balance and exposure that has kind of changed.
All right, so the light show continuing. We are through the period of peak heating, and we'll be looking at the peak pressure coming up in the next couple of minutes. The next 10 minutes are probably going to be the spiciest of entry today. As a reminder, we are going to be doing some stress work on this ship, where we're going to do a maneuver where we kind of kick the nose up to fully deploy those aft flaps to really get a good test of the structural strength of that part of the ship. We did that on one previous flight test on version 2. We're going to try and do that today. Since we did skip the in-space burn, we're carrying a little bit of extra propellant in our header tanks up in the nose. And so that's going to put a little bit of extra stress on those forward flaps as we come in. So we will see if they're able to hold through that reentry. So that will be another watch item. We did skip that in-space burn, but we are expecting at least 2 of those sea-level engines to try and ignite for a landing burn. We entered the entry period in a good attitude. So hopefully making our way to the targeted splashdown point. We've got that Starship recovery team standing by. And we should be about 10 minutes away from splashdown. So a lot of excitement over the next couple of minutes. Kate and Jake, let's see how Starship holds up on the way in.
Yeah, and we just heard on the nets there that engine chill has started. So essentially what that means is we are prepping the landing engines by getting them down to temperature ahead of that landing burn later in the mission here.
And on a lot of our previous flight tests, we've been removing a bunch of the tiles. If you've watched those, we were really intentionally trying to push ship beyond its limits. On the last flight, we even had basically a hole get punched into the liquid oxygen tank that you could see when we did the landing burn into the ocean, and this ship was still able to make it. But right now, we're really going to be testing the structural strength of these flaps on the way in. Again, this is a flight test. We're trying to intentionally find where our limits are. And in this view, you're looking at a whole bunch of tiles. I think Jake talked about it earlier. We bonded some additional tiles to the leeward, or kind of the metal side of Starship, to see how those different bonding techniques would hold up. And looking like we've got quite a bit still attached.
Good experiment.
Yeah, and as we're going down through the atmosphere here, we are at about Mach 16.1. So still extremely fast, although we have, scrubbed off a substantial amount of our speed already. Altitude at a little less than 60 kilometers.
Still more work to come. But hopefully, hopefully we'll see a splashdown here in less than 10 minutes. I am curious when the engines light up if they're healthy enough and if they had any major leaks or anything
we're
from
about
that
8 minutes
RVAC shutting
away
down.
from our targeted landing and splashdown time. Again, this is when the ship's going to start really
Ship
getting
is
put
approaching
through
the
ringer.
end of the peak heating region.
Just heard the call out, getting to the end of the peak heating, so the highest temperature the Starship's going to see during its re-entry.
Whoa. It's getting sparkier. Likely is some material ablating away, so I'm curious what's going on there in the nose, if that's okay or if that's
This camera angle
not intended.
changes as it is attached to the forward flap on Starship. So we're actually experiencing the articulation of that hardware, helping to steer the ship down for its precise landing in the Indian Ocean.
I love watching
Yep,
this.
that
This
is
the
just a
coolest
really
thing.
cool, kind of cool piece of perspective there. I know some people say it makes them a little seasick, but I definitely love it. It makes it feel like you're really riding along with the ship on the way down.
Yeah, if this thing, Discord, I agree, Earthrise, if
Yeah,
this thing
and aside
actually
from just
sticks
looking
it-
cool, all these camera
Like-
views providing just really critical data on how the heat shield, how the flaps themselves are holding up. That's why we've got these in the flaps and then all scattered all around the ship so you can see how they hold up. There's some internal to the vehicle too and we're getting all of this video back via Starlink. Even as we're just enshrouded in plasma, we're able to kind of operate at a high enough frequency to punch through, and that is blue ocean and sunlight you're seeing just beyond the flap. So we are coming down into daylight, hopefully splashing down in the next 6 minutes or so in the Indian Ocean. We've still got a couple maneuvers lined up where we're going to be really stressing the flaps on the ship. So
Ship has passed through the peak heating region. External temperatures are coming down.
Wow, that is incredible news. As Dan mentioned, we were expecting this reentry to be super spicy, but excellent news that we're now past that period of peak heating and that now the external temperatures are starting to decrease.
If they,
Those
if this
heat shield
thing
tiles
still lands
there
on target,
the belly of the ship, really doing a ton of work to burn off all of that inertia that the vehicle had prior to re-entering the atmosphere.
Yeah, and you can tell by the G meter down on the bottom right that we're starting to pick up a couple more Gs here, so we're definitely entering the thicker part of the atmosphere where we're scrubbing off all that energy, like Kate's saying.
so coming up on only about 5 minutes or so from
all right,
intended
just about
splashdown.
5 minutes or so to go. We're coming up shortly on the maneuver where it's affectionately called the flap slap, where we're going to kind of pitch the nose up on the ship, and you're going to see those aft flaps, the ones in the very bottom, fully deploy.
There we are. Whoa. So that's like maximum
Ship is at
braking,
peak dynamic
basically.
pressure.
That's like slamming on the brakes.
And we're now at peak pressure.
That's so cool.
Ship flap load test has started.
Wow. That's so cool.
Looks like it's holding.
Yeah, that's incredible.
Again, the intent of that was to put just a lot of extra stress on those aft flaps. We are expecting the forward ones too to see a little bit of extra stress as we've got a little more propellant in our header tank, so the area right at the very nose of
Ship
Starship.
flap load test is complete.
And we're through that
Excellent.
test.
Impressive.
There we go.
Impressive.
And we just did that test at Mach 7, just for reference there. So we are still going incredibly fast.
Okay, about 3 minutes away from an intended
All right,
splash
we
off.
are
This
just
thing
about
lands.
3.5 minutes or so away from our targeted landing burn. Again, we're Expecting to try and see 2 of these Raptor engines light for the landing burn. Normally we plan for 3, but we're going to give it a try with 2.
Interesting. Or if that's something to do with the engine out, or if that's a...
Hopefully we've got
Ship
Seren.
is starting the RTLS banking maneuver.
It's a return to launch site banking maneuver.
And that
So
right
we'll likely
there,
see it.
so we're starting a banking maneuver, and essentially what that is when we come back to Starbase, or when we plan to come back to Starbase, the trajectory is designed so we'll essentially swing out over the Gulf and do a swoop maneuver to then come back to the towers for catch. And so we are doing that exact same maneuver as we head towards our targeted splashdown in the Indian Ocean.
Yeah, and that call out there that we heard, RTLS, stands for Return to Launch Site. So definitely a pretty cool thing we're demoing here on the ship. You know, as in the future, we are going to be trying to bring the ship back to the launch site, which is going to be absolutely insane.
Absolutely. But of course, we want to test out these maneuvers, these principles, prior to actually bringing the hardware back to the pad. This is the same reason why we were intentionally not trying to bring the booster back to the pad. So we're trying all these things out in this developmental phase of the vehicle, and really proving what a test flight is.
Absolutely.
Dynamic pressure is coming down.
All right, we heard there dynamic pressure coming down, and I'd say we're in a pretty good bank right now.
Yeah, executing the power slide. We're about 90 seconds away from our anticipated landing burn. Clouds coming up, pretty sunrise on the other side of the planet.
Man, it looks so controlled.
Starship is subsonic and is on target.
Subsonic and on target, despite engine out.
The crowd here reacting to that call out, letting us know that we are on target for this precise landing in the Indian Ocean. This will once again be a soft splashdown.
Yeah,
we should get some pretty cool views from the recovery team who we chatted with earlier. They are standing by to receive this ship. Once again, this is the first flight of our completely redesigned Starship version 3.
Yeah, and if you remember the suborbital flights from a few years ago, this is very much the same regime that we're in here. So we're sub 15 kilometers executing what we call the belly flip maneuver.
Yes, serial number 8, the first belly flop. I remember it well.
So I'll try to answer a few more questions at the very end, but then I got to wrap up here.
Amazing views of the Earth as the ship is coming back home. Thanks,
I won't call it
Starlink.
telemetry anymore. Here we go. It's getting down to the last little bit here.
Yeah, you can see the aft flap there making minor corrections.
Starship is turning for final approach to landing site.
Look at that turn.
There we go. Minor corrections and a full turn.
Wow. Wow.
Yeah, Starship doesn't fly like an airplane. It's a lot more like a skydiver. Full belly flop on the way down, using those flaps similar to arms to help change the path of the air over you. Coming up real soon. Again, going for a landing burn, trying to light 2 of these Raptor sea level engines.
Here we go. It's coming up soon. It really does look in pretty good shape. We'll see how this turns out, though.
Landing burn startup. 2 engines lit. Successful flip. Buoy can't catch
away.
Good shot time.
Oh, yeah. Let's see it. Let's see it go boom. Thank you for keeping the boom on it. Wow. Thank you, SpaceX. That was incredible. So they nailed the target because they had footage of it. They nailed it. Oh, that's outstanding.
It's exactly what we wanted to see for the ship today. As weird as it may sound to hear, but it is the truth.
Absolutely wild. You know, at the beginning of the show,
We're pretty hyped.
we guaranteed excitement at the beginning of the show, and I'd say Starship delivered.
Absolutely. An incredible day for Starship. That was the first flight of that completely redesigned vehicle. As you can tell, the teams are incredibly proud of what we just saw.
Yeah, V3 definitely showed up. That was amazing.
Yeah.
Yeah, we've pretty happy crowd in the control room behind me, I will say. It's probably the most excited I've seen a lot of people in a really long time. On target landing.
Good.
Wow. Actually, let's jump over. Hey, Tyler, how's everyone holding up in Hawthorne?
We're having a great time, Dan. Thank you so much. That was another exciting Starship flight in the books, and we hope that you enjoyed those awesome Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that wraps it up for us here in Hawthorne. Thank you guys for tuning in, and back to you, Dan.
All right, thanks. So just to recap, we lifted off right at the top of our window, 5:30 p.m. Central Time. We were able to see the booster light 33 of those Raptor engines get off the pad and ascent over the Gulf. Successful hot stage separation. Initially lit 6 of those Raptor engines, lost one of the RVACs on the way uphill, and then the booster didn't complete its full boost back. Its mission ended a little bit early, but landed in the clear area that we had set in advance. Once we were on orbit with ship, we were able to get through our payload deployment, 22 satellites, the 20 simulators, the 2 Dodger Dogs, which successfully turned on cameras. We'll see if we got any more views from those. So obviously stick around. Skipped the Raptor relight, but made it through re-entry, on target landing in the Indian Ocean. You saw those views. Starship made it. It's been a long time coming. We're really excited to see this vehicle fly, and there are several more on the way. So that's going to do it for me up here. Send it back down to Kate and Jake and everybody who I hope is at least a little bit excited down in Star Factory.
Oh yeah, it is absolutely insane down here. We would, of course, want to thank the fine people of Cameron County, including the residents here at Starbase, as well as the Coast Guard, the Federal Aviation Administration, the Government of Mexico, and of course, the Australian Space Agency.
Yeah, so honestly, just huge congratulations to all our teammates here at SpaceX and everyone who's supported the Starship mission just in general here. It's been a massive effort, really incredible.
Yeah, there's a lot of people that worked really hard to make things look easy, so shout out to those teams. Now be sure to follow SpaceX on X for updates and more exciting views that we didn't get to show you on today's live program. I have a feeling we'll see some pretty amazing stuff come from those demonstration satellites that we were able to show some initial footage of. Now, if you're interested in more launch coverage, head on over to our profile on X. We also have spacex.com/launches for you to check out for the most up-to-date information. So thanks to all of you for tuning in. We're going to close it out and celebrate with our colleagues. Thank you so much for tuning in, and have a great night.
Okay.
We'll see you next time.
All right. Awesome. So again, thank you guys for watching with me. Yeah, we're probably going to try to pull up a few replays here. Let's watch this replay of the satellite deployment as well. And I'll try to answer a few more questions. We'll do one of our replays, and then I got to get out of here. We're going to get kicked out of here pretty soon. So I'm going to work my way eventually towards some sleep, some much needed sleep. So I love that view, though. I am overall very impressed. The drone shot in our Discord channel, people are posting. Thank you guys for posting stills of it before it splashed down. It is looking really quite good. The heat shield looks outstanding. It looks the best any heat shield has looked, and it really seemed to hold up pretty well. The fact that it was still able to be on target despite an engine out, really impressive. I'm shocked. That was great. That's actually a really good test. That's in some ways a lot better test than what you can expect with a totally nominal situation. So the fact that they were able to see what happens because those RVACs, they're all the way out on the outer perimeter, and when one of them goes out, it puts a lot of pressure on the other two, and it will want to pitch, opposite of the one that's or I guess pitched down towards the engine out. So the center Raptor engines then will have to compensate for that and gimbal opposite of that. So the fact that it still landed on target, clearly landed on target where they had enough drones to be able to catch it. It's not like it landed even 10 kilometers away or something. It landed on target where it's supposed to, despite all those challenges. So that was really, really actually quite impressive. So just huge shout out to SpaceX teams and all the people that made that possible. Really, really fun to see. Sorry if I missed your comments. I had so many, that I had to miss as I like to listen in, and I'll try to get to a few of them here real quick. But first, if we have time, I wanted just to remind you guys one more time, if you want to support the work I do, I really appreciate all the super chats and all the memberships. They really help us be able to do the craziest things that we're doing, like trying to have me stream halfway across the world while we have teams spread out and just the craziest setup. So again, thank you for bearing with my audio sync issues and things like that. Hopefully we'll never have to do it quite like this again, which, it's impressive what our team can solve. But if you do want to support the work we do have our shop at everydayastronaut.com/shop. You can get some cool new merch for yourself, including the shirt that I'm wearing, which is our Translunar Co shirt. And this is our slow roll towing shirt. Sorry, it's not a Translunar Co shirt, but it's our Translunar collection. If you use the words Starship, all one word, all uppercase, Starship 12, you can get 10% off. I think it's 10%. Maybe it's 12% off. I don't remember. It's a certain amount off. You'll find out in the shopping cart. You'll know more than I do. Anything in that. And then as well as our heat shield collection. So our heat shield button-ups, our heat shield color changing mug are also on sale today as well. So support the work I do. Oh, we also have these, our Methalox hoodies are finally back in stock after like 6 months. So a lot of people have been asking about those. They're finally back. They're outstanding. New orbital shirt collections that are new colorways in those as well. And then of course our color heat shield collection. So everydayastronaut.com/shop. And help support the work we do here. Help keep us on air. And thank you guys so much for supporting. It really does mean the world. So speaking of support, let's see if we have anything from, are we ready to queue up some stuff to show a replay of launch? Okay, we don't have anything to show. So I'll answer a few more questions. Let me know if we do. I have to be getting out of here in about. Okay, so likely we will not be getting a replay, but unless something changes, I'll let you guys know. But we've got people. This is a good question from Utopian Pigeon asking if they recover parts of the booster for research. They actually did recover some of the boosters from the Gulf because it is pretty close. But this one splashed down a lot further, still within the exclusion zone. But since it didn't complete its boost back burn, it might be a lot deeper. It might be a lot harder to recover. But they do seem to like to get the data out of it physically when they can, which is really cool. So. Yeah, also RGV Aerial, shout out to RGV Aerial. They're going to be getting pictures of the conditions of the flame trench now, which is really exciting because I am very curious how the pad turned out after all that. That is obviously one of the biggest upgrades and one of the biggest question marks is how did that brand new pad 2 turn out? Hopefully it did good. Well, thank you so much for Turntable Slave. I appreciate it. Again, there's going to be so many that I am missing. Spooky Spaghetti becoming a member. Let's see. In what way will this impact the Sandikins? I don't quite know that reference, but thank you. This is a very commonly asked question. Has SpaceX ever considered a Falcon Heavy style version of Starship using 3 super heavy boosters strapped together? If not, your thoughts. They almost canceled Falcon Heavy because of how it was literally done. And Elon was like, hey, we're just canceling Falcon Heavy. We're just moving on to Starship because they hated it. Ends up being really complicated. The engineering workload to strap 3 boosters together. It's so much easier, relatively speaking, to just scale a rocket up bigger. And now they have a massive site. They have a lot of room to grow the vehicles taller. As engine thrust increases, they can just make it taller, increase performance. There's plenty of room to go there. And they've said a few times that the tricore is not ideal, basically. I missed the old school launches when you had no fancy equipment. There's only a few of us. Well, I am sorry, but that is, the fancy equipment. I know sometimes it's harder than it's harder than me just having a laptop watching a stream. But at the same time, I'm so proud of some of the tracking shots and the things that we get and the way we're able to cover these launches is absolutely incredible. Especially if you look at our Artemis 2 launch, that should tell you everything. We had, objectively, I think we had the best Artemis 2 coverage, even better than NASA. And I think a lot of people would agree with that. So It's a big investment, and we have an incredible team that runs it. So huge thanks. So yeah, and speaking of that, everyone give a quick shout out to Spencer and Ryan and Andrew and all the people, Ben Steinman, all the people that have worked really hard behind the scenes, even either they're on site or remotely to help make this possible, to our production team, but also to our mod team, including Moondust Lisa, who is staying up very late in the UK, helping as well, and all the other moderators that make this stuff possible. We really, really appreciate you guys. You are the heroes that help keep the glue bound together or whatever. I don't know what we're saying. This is cool. This is shout out to my son Aiden, who graduates from Allen High School today and is about to begin his engineering path. Absolutely incredible. Love to hear that. Best of luck, Aiden. We're cheering for you. We need good engineers. Hello to my friends at Minos Encore. We're mostly just doing shout outs here, but I do appreciate it. I'm going to make sure I'm not missing anything. Yeah. Let's see. A Starbase tour would be fun if they open it back up like that. Would be really fun to see in there again. Thanks for the coverage, Tim. S39 looks like it's in pretty good shape. I agree. Hello to Scott and Stony Plain. Happy birthday. That's awesome. Okay, I think I need to Carla forever, please. I don't know what that means, but thank you also to Carla, and Lucas. Yeah, I think I'm going to wrap it up here, my friends. Really appreciate you sticking with us even through a very, very, very difficult streams. Thank you, Christopher. Through a very difficult situation, and I'm glad that we were able to still pull together an impressive stream, hopefully, or at least a decent enough stream. I really appreciate you watching with me. Thanks to the folks at Nerdland Festival, too, for sticking around and helping me stream this late. I really do appreciate your guys' help as well. So together, we were able to cobble together something, and pretty great. So, all right, thank you guys so much for tuning in with me. That's going to do it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people. Goodbye, everybody. Maybe.
Thank you.